Well, hello everybody. Welcome to SkyTour Livestream for this February 9th, 2023. And as always, we have with us our wonderful co-host, Daryl Mason. Hello, Daryl. How are you doing?
Hello, Mark. I'm good, thanks. You? Hello, everybody.
I'm doing good, thank you. Very good. And we're checking out the Comet one more time because, well, not one more time, but we'll be doing it again. It's just that the comet is really very pretty. It's also windy out there today, so we're going to have some kind of fuzzy streaks for stars a little bit, but that's okay. I do want to take the time to say hello to everybody that came in. We have PG, Petita, who's here with us from Pennsylvania. Hi, Petita. We have Rocket City Astro. What's up, man? Nice to see you. Donald Kunzer. And we have Michael with us. Michael Hedrick, good to see you as well. CND Boy out of Canada. Daisy and Zoe Amethyst, so nice to see you guys. And I know they're not going to stay long because they've got doctor's appointments tomorrow. They say so in the chat. Robin Curtis is with us. Hello, Robin. Simon Thompson from Oz, down in Australia. Nice to see you. We have Cosmic Ray. What's up, man? Yes, this is the geology chat. We're going to only talk geology. What's astronomy? I have no clue. And let's see who else has joined us early on here. We have Maziv. Hi, Maziv. And we have Cyclone with us. And we have Elisha and Venus. Hello there. It's nice to see you. Thank you for showing up and coming out to see us. This is really nice. Elisha and Darlene. Wonderful. Anahata 77. That's Bonnie. Hello, Bonnie. Nice to see you. And we're going to bounce around to a few different things. And Rocket City Astro is Michael Klages, who always comes to our stream. Thank you, Michael. And he's on his telescope tonight. What are you shooting tonight? You shooting the Comet tonight, Michael? All right, so let's actually, while we're waiting here, the sky may not be fully dark out there, but let's give it a shot. Let's see what we can do. Let's do a 25-second shot. See if we get blown out or we get data. All right, and we'll stack this, of course.
Barbarina is here.
Hello, Barbarina. How are you? Nice to see you. It's so nice to see you. I was talking about your dad, actually, to another colleague earlier today, actually. And I think I mentioned this to you as well, that when I was getting my degree in astronomy, Fritz Zwicky was one of our mainstays, from dark matter discussions to other types of discussions. So it was actually quite nice. So you really threw me for a loop by coming into our stream. I'm humbled, and I'm so happy you've come. All right, here is the Comet is tonight. Oh, look at the tail. Look at the tail. It looks beautiful. That's the ion tail right there. The dust tail's right here. And we have our... I'm going to color correct it to make that tail stand out a little better. There we go. Look at that. So this is the cyanogen, diatomic carbon atoms, elements and molecules, actually. Cyanogen is a component, but cyanogen is usually CN parenthesis 2. So it's like two molecules of CN, okay, carbon and nitrogen together to make the cyanogen molecule. And when ionized and when the electrons recombine temporarily, they give off energy and the light comes out in green. Same thing for diatomic carbon, which is carbon-carbon. Okay, and carbon's interesting because carbon has 4 electrons in its outer shell that can bond with anything. So you can literally get 3 electrons bonding to another carbon. So you get carbon-carbon, really nice and solid 3-electron bond there, right? Really interesting. And so, again, that's why we get a copious amount of this green light, because those electrons are always ionizing and coming back in from the solar ultraviolet energy that's hitting them. So it's very cool, and as you can see, the dust tail goes one way, the ion tail goes a completely different way. Let's see if we can exaggerate that just a little bit and make it a little more obvious. All right, so there, look at that. I mean, we got a lot of color in the tail tonight, Daryl. Look at that. Yeah, we do. Okay. There we go. Look at that. Now we got a nice tail. I'm going to actually save this right here, but I have to, first, I have to, oh, that's the wrong thing. I got to get us back to our E3 Zwicky Transient Facilities ZTF object here. And now we'll save it because that tail is actually really, really obvious. It's very nice. Save exactly as seen. Barbarina, one of the things I wanted to mention to you is if you'd like to come on the air with us at some point to talk about your father, I would very much be honored if you would, if you wanted to. You know, because there's a lot of stuff out there that's written about him. Some of it is right, some of it is not. And if you want a chance to talk about what's right, I'd be happy to give you that forum. You've certainly earned it. So let me know. It doesn't have to be tonight. It could be, you know, any other night. And we do have a Sunday night radio show on KGRA called SkyTour Radio. So we have SkyTour LiveStream and we have SkyTour Radio. So you could come on one, both, or none. It's your call. Just give you the opportunity if you want to. Or you can just watch and enjoy. I don't mind. So let me know. And here's Marianne Robb. Marianne Robb is 1/3 of the SkyTour Livestream family, the people that put this all together. You know, the other one is Tara Diulis, and of course myself. Daryl is our wonderful co-host who works with us a lot of the time. He's also the co-host on SkyTour Radio with us. So it's really kind of a family event, right? We teach you astronomy whether you know it or not. Hello, Cindy Murphy. Nice to see you. Nice. So, this really looks pretty. I'm very impressed with this. And
Yes, very nice.
if you notice, the wind seems to have died down enough so that we're getting a nice, pretty even look at it right here. I'm going to do one more save. And save exactly as seen. Then we're going to clear. Yeah?
Is it just my imagination, or does the dust tail look a little skinnier tonight?
I was actually thinking it looks a little wider. But maybe not. I'm just finding the dust tail, or the ion tail, to be spectacular. In fact, what I'm going to do is move the Comet over here. Because I think that I want to see if there's the rest of the dust tail out there. Sometimes, I'm sorry, the ion tail. When the ion tail, or the plasma tail as they will call it sometimes, at the end you'll see knots and twists in it. And I'm wondering if we're going to see that here, and that we're robbing all of you of seeing that. So I'm going to find out in just a second, because I'm going to go ahead and do that. But first I'm going to make sure my camera's right. Okay, there we go. All right. So here's what we're going to do. We're going to go to 1 second exposure here, because I use that as a base exposure. And then we go and we do this setting where I actually bring us up to maximize the view, give us like a night vision view.
Elisha Veras has a question. May I answer her?
Sure. I read the question too.
Yes. Elisha, she's with Darlene. Darlene would like to know, she's in the 3rd grade, if you know when the next time will be that we can better see Mars. Darlene, Mars comes around to a place called opposition when it's 180 degrees from the sun in the sky, opposite the sun in the sky, when it's closest to Earth and therefore biggest and brightest, about every 26 months on average. And the last time here it was on December 7th, 2022. So next time will be approximately, let's see, February of 2024. Is that right? 2 years?
Yeah, it's every 2 years.
December 2022, so December 2024 plus 2 months, about February of 2025. My mistake.
Okay. Okay.
Mars is farther from the sun than Earth is. It's a superior planet. It orbits farther out, and therefore it orbits slower than Mars. So we're slowly moving ahead of Mars in our orbit about the sun, and Mars is falling behind, and it'll eventually fall into the sunset months from now, and then it will reappear in the morning sky, and Earth will catch up to it again in February 2025.
We can show you in pictures, but we're not prepared. If we knew, I would have prepared a little diagram for you. Okay, we're going to do this again. And for those that may not know how we're capturing our shots, I'll just say it here. What we do is we take a picture, and you see the first picture, which you're about to see in 4 seconds. All right, and that first picture is usually a little grainy because it's the raw image. See, like that. Okay, look at that long tail. And but that picture, let me just back us out a little bit. All right, that picture is the start, and when the second one comes in, you'll end up seeing that a lot of this colored noise goes away. All right, and we'll see that in 7 seconds. When the next image comes in, you'll see that space starts to get a little blacker, and this stuff gets more defined. All right, so here it is. Watch. Look at that. So now that starts to look a little better, and then we can start doing some processing like this, and start working with the colors and get the colors to come out a little bit. Okay, very nice. It looks nice. You can see that long tail there. That's just beautiful. Wow. I had something else to say, and I can't remember what I was going to say. Oh well.
Sam thinks you're not in focus.
I did a critical focus before, but let's go. Well, okay. Sam, we have wind out there, so the images may be a little out of focus. Let me just zoom in here to...
I think he means you. You're not in focus.
Meaning this camera? Wow, the stars are in focus. Ray says the comet's reported magnitude is 6.5 now. Actually, it's more like, if I recall, it's like 8. Let's take a look at that. Let me get the exact magnitude for you, Ray, because I do remember. Yeah, the observed magnitude is 6.3. Okay, sorry, it's the estimated magnitude. Okay, from Jet Propulsion Labs was 8.76. So yeah.
You look pretty in focus to me. You're just colorful, and you got a little edge around your head.
Yeah, I wonder why. I have a little edge. There's an edge to me, guys. Oh no.
Kind of shiny.
There's an edge to me. I could shine more with my astronomer glasses on. How about that? Yeah.
Izabela's here. Hi, Izabela.
Izabela, hello. Izabela is in Bulgaria, and she's one of our most ardent supporters. She's one of our Patreon members. She's a patron of ours. So nice to see you. Our patron list is right here. These are the patrons we have. We have John P, who just joined us the other day, Izabela, Ali B, Chief McCyber, Vera, Lucia Campos, Ronald T, Martin W, and Raymond B. And that list is gonna climb, but I just wanted to make sure that everybody got their proper shout outs they have so earned. Yeah, and Michael Klagus, Rocket City Astro, was saying he's getting a tail tonight. And we have it. See there, we have finally got a nice tail. And it really does look a nice color. Now, we don't have the moon up right now. When the moon comes up, subtle colors like this will get washed away, unfortunately. But we have it now. That's pretty. If we actually if we zoom out a little bit, you can see it better. Because the colors are compressed into a more of a smaller space. Let's see if we can do a color correction. All right, I'm gonna do a manual correction here. There you go. There we go. Look at that. So now you actually see the tail very clearly, and the dust tail is right there. The dust tail is sort of a yellowish color because it's sort of reflecting sunlight. And this tail is bluish green because it represents plasma. That is, what's plasma? Plasma is protons and electrons. Usually in this plasma tail, there could be streaming electrons that are streaming back behind the comet, and they're glowing because they have been ionized and caused to glow as they interact with the gases that are being streamed back with it.
Izabela, hopefully.
It's a little windy tonight.
I told Marc about it. Hopefully he got a look at it, and if the wind dies down, then we can try it.
And it will. Fantasy says, "Thank you, Mark, for pronouncing my name correct." That's okay. Let's see, Justin Fletcher. Hi there. How are you? So how far in between Mars and Auriga for backward observation purposes? Oh, why don't we check that out? Because we'll go to our planetarium program, right? And here is Capella, all right, which is in Auriga, which is pretty high up right now. It's almost overhead. Actually, let me do it this way. This is from our location. Okay, so Capella is almost overhead. The comet is almost directly overhead right now from Connecticut in the United States, okay, in the northeastern United States. And there is Mars. Tomorrow the comet's going to be right down near Mars. And we will stream tomorrow to check out Mars in the same field of view as the comet. All right? At least it's predicted to be, and I'm pretty sure it will be. So that'll be nice. All right, so that's about where it is if you look in the sky, all right? And so, Auriga up here, all right? And Taurus, the bull, down here. Mars is in Taurus, the bull, right? And what you'll see when you look in the sky is you'll see Mars just almost directly overhead in the United States. And you'll see Capella, the bright yellow one, which is on the other side of overhead. And between those two, on a line almost between them, the comet is just past the midpoint right now, just past the center point of overhead. And it's a little closer to Mars. Tomorrow it's going to be right there. So if you look at Mars with binoculars tomorrow, you might also be able to pick up the comet, all right, in the same field of view. Again, if it's a darker sky, all right. The comet is just beyond perceptibility for the human eye without being in a dark site. If you're in a dark site, you would have to use binoculars to see it anyway. But that's where it is, to answer your question.
Could you possibly go back to that other grid pattern you had?
Oh yeah, that's the equatorial pattern. Let me get rid of the altazimuth grid and go into the equatorial grid. This is the Earth's coordinates extended out into space. Go ahead.
Okay. Are those increments 5 degrees?
These increments are 10 degrees. This is 10.
10
This
degrees.
is, unless I zoom in. If I zoom in, okay, then they go down to 5 degrees. So if we get rid of this for a minute, okay. All right.
That's okay. So that's 5 degrees. Let's see, 5, 10.
It's about 5 degrees
15,
to the comet
20.
from Mars.
Yeah, well, he was at he was asking Auriga to Mars, or from the star, the bright star at the bottom of Auriga.
Oh,
From Capella, it's looks like 20 degrees or so.
yeah, it's going to be about 5, 10, 15, 18, maybe roughly 20, yeah, to the comet. Yep. and it's only about 5 degrees from the lower right star in Auriga to the comet. Actually, if you draw a line between that star and Mars, the comet is just about in between, maybe a little bit more toward Mars. So that's the star hopping methodology for getting there, right? So let's do this. Zoom in. So there's Mars, and there's this star. This star here, okay, it has the romantic name of Hasala, okay, and it's is that Iota? That's probably Iota, okay, Aurigae, and then you have Mars down here, and so just about halfway, a little more than halfway to Mars is where the comet is on the line between those two stars. All right.
Well, just click on that star again. Also known as Cabalanan.
Cabalanan, yeah.
Yeah, because the star on the other side of Capella is Menkhib.
Oh, yep. And then we have Elnath down here, but it's this star here.
Actually, Beta Tauri.
Yeah, this star here, Cabalanan, at the lower right side of Auriga, and Mars. Draw a line between those two tonight, and the comet will be there. In fact, for the next couple days, the comet will be along this line. So that'd be pretty cool. All right, so there's our telescope. We're gonna center on it. Okay, now just show you real quick. All right, we're in here now. Notice that if you look at the screen here, this is our field, and the stars that you see in here are going to be reproduced in our field over here. Okay, now we are actually wherever we are. Okay, let's say we have this star here, that star there, and then we come into our thing here, and there's that red star right there, okay, and that bright star right there we just talked about, in this star here. So there they are. The field is reproduced quite accurately.
About to say, that's quite a red star you have there.
Yeah, actually that's this star right here. That's a Hipparchus catalog star, Hipparchus 22400, or the Henry Draper catalog HD 30482, or the Smithsonian Astrophysical Observatory catalog 76772. How romantic these names are, right, guys? Hey there, Marco.
Donald Kunzer has a question of you.
Cabalanan. It may be Arabic, yeah. I'm guessing it is. But I don't know for sure. That's more of a Daryl question. Sometimes he knows those things.
I can't say positively. Fantasy says he speaks Arabic, and he hasn't encountered that word before. Many star names are Arabic, Donald. Capella, the goat star, I'm not sure about it either, actually. But yeah, a lot of star names are Arabic.
I could actually find out all this information, because I actually have a big thick book that goes over all the star names. So I could look up Hasala or Cabalanan. See, Hasala, this is Arabic right here, okay? This guy right here. This is the star that it says Cabalanan, but Hasala is Arabic.
That sounds Arabic, yeah.
Yep. All right, let's go back to our comet. What do we got? Oh, look at that. Oh, what a night. What a night, huh? It's beautiful. In spite of the wind.
The tail actually extends a good ways across the field there.
Yeah, that's why I moved it over, so we could see it. I could go even further because it actually leaves the field. Now, keep in mind, guys, this field is 4 full moons across, side by side. So that's just over 2 degrees, okay? Right there, 2 degrees. And it's about 1.5 degrees tall, so 3 full moons tall, 4 full moons across. So, hey, I'm telling you, it's really pretty interesting. Hello there, Lysiana. How are you? All right. All right, so we're going to save this so we have it. and we'll save it exactly as seen. Then we're going to clear, go to our night vision mode again, and give ourselves brightness, and then we're going to move over even more. All right, and I'm going to go north with the telescope a little bit just to bring that coma, the part there that you see on the right, down some. Okay, so now we're going to let things stabilize. You'll see here that we're searching for our guide star. Now we're guiding. We've calibrated to zeros, and now we're guiding. So we'll give that a moment to stabilize. Looks like the sky is calming down out there. And we're going to do a 25-second shot again. Actually, 30-second shot. And we'll catch this again now. And we'll go back into our live stack and wait for this to come in. And I'll remove this adjustment. Hello, Lucy Clark. How are you? It's a pretty sky indeed. All right, and we are... All right, here we go. Okay. Wow, that's pretty amazing. The tail goes all the way out of the field. So the tail is literally over 2 degrees long, as you can see. It's over 2 degrees long. That's pretty cool. That's neat.
See if I can find a source.
For what?
For Kabalanan.
Oh, okay. Well, Hasala is probably the given name, and I don't know where Kabalanan comes from.
Well, the star right on the other side of Capella is Menkhib.
Yeah.
And
this is Kabalanan, so the only thing that's similar is the INAN. I don't know. It might be have something to do with it. You could be right. Look at that beautiful ion tail, that plasma tail, stretching millions of miles. That always points directly away from the sun. So if you were to draw a line just like this in the sky through the head of this comet and just keep going, you'd never hit the sun. So it's like, well, how can that possibly work? The way it can possibly work is if we're looking at this and it's highly foreshortened in our view, meaning this part is much closer than this part. This part is way further away and it's going into the page at a long distance back. So you can't tell that from looking at this, but if you went next to this comet, you'd be riding next to this tail further out into space, millions of miles. You know, maybe a million miles. I'm not. It could be that long, and then you end up finding yourself, you know, far away from the comet, but still getting these ions, these beautiful blue ions from this electron stream coming off the coma, the nucleus.
Menkhib is an Arabic name.
Okay.
Its Arabic name comes from the phrase Menkhib du al Inan. I don't speak Arabic, but Menkhib du dhu al Inan. So if the other one is also an al Inan, it might have a Arabic root to it.
Yeah.
Still looking, bear with me.
No worries. Okay, that gives us the tail pretty clearly there. That's nice. Look at that. Okay, we'll save. Okay.
Oh, okay. Iota Auriga, also called Hasale.
Okay.
And it's not Kaba, it's Cab D-H. I-L-I-N-A-N. Cab Dillanan. That sounds more of a Arabic name. Still looking. Kabdalanan.
Okay, then you're saying it's spelled wrong here? Kabalanan?
Yeah, it's Kabdhilanan.
Oh, Kabtalanan.
Kabdalanan.
Okay. Hasala is the actual, or one of the names for Iota Auriga. I thought that was an iota. Okay. Good.
The traditional name Kabdalanan, sometimes shortened to Al-Kab, comes from the Arabic phrase Akab del Inan, meaning shoulder of the rain holder.
All right.
So it is Arabic.
Yeah, and Kristen W says the name Hasala, pronunciation Hasla, I could have that wrong, comes from Czech astronomer Antonin Bekvar's Atlas Colae. Yeah, I have Atlas Colae and Scale-Innate Pliso. I have both of them. I have the Scale-Innate Pliso, actually. I have several versions of it in the back here. Origin is unknown. I think that it's probably Arabic, Christina. Thank you so much.
I have a Scale-Innate Pliso around here somewhere, too.
Oh, yeah. Yeah.
Nice Atlas.
Yeah. Anton Bekvar's Atlas Colae. Or Coeli, as some people. I say Colae. Yeah. You know, us astronomers, we have these atlases of the stars that we always have and have had growing up. And when I was 9, you guys know this, I knew I was going to be an astronomer at age 9. And I never wavered. I kept with it. I migrated for a bit into oceanography, thinking inner space, outer space. Here, not so much, right? So, but it was really cool, and so I decided to take myself down or out into space. Actually, I want to say hello to Greg O'Brien, who has showed up. Hi, Greg. How you doing? And D. Smith is with us. Nice to see you, D. Very nice. And I want to remind everybody that tomorrow, the Comet is going to be closest to Mars, and we're going to be streaming that as well. It's going to be really pretty. Very pretty. What a beautiful image. Okay, we're going to save this guy. Save exactly as seen. All right. Now let's go back here, because right near us here is another object I want to capture. It's right about here, and I want to make sure we can capture it. I don't see... It's here, though. I know it's here. Maybe I gotta move over. This might be it. That might be it. This it? This it? No.
What are you looking for?
The Perseus cloud. I'm trying to remember where that was. That's that's near here. I'll look at it. Oh, there it is. Okay. For those of you that know me, you know that one of my hot buttons is the dark clouds in the galaxy and the dark dust. This dust in our galaxy has served to basically give us brings life to our galaxy, basically, because what we have here in this darkness is we have this most amazing collection of elements that were created in the hearts of stars. And so we're going to go to one of those right now. This is called the Perseus cloud. We will come back to our comet in just a little while. And if you notice the stars around the comet, you'll notice that they will have changed because the comet's moving down this way. And you'll actually see that, all right? And when we come back, you'll notice that, all right? So keep in mind, all right, that the comet is moving sort of in this direction. So you'll actually see the comet moving visually from minute to minute, and that's kind of fun to see. All right. So let's come out of here. Let's we'll clear this when we come in next time. Let's go into our night vision mode so we can see our view, what we're looking at. And there we go. Let's get the night vision going. There we go. All right. And now let's head over to the Perseus cloud. All right. Notice the telescope up there moving. Can't miss it. And we're going to increase our sensitivity to 350. And the sensitivity is a very important parameter. Let me just show you real quick. The parameters that are most important here, all right, are this one here, the exposure. That's how long we're going to expose the sensor. And then this one here, which is the gain. These are the two most important ones that we look at. This down here, this is our focus section here. This is a adjustment location where you can do global adjustments in brightness. All right, but for the most part, we will use the exposure and the gain. Let me just go back here and make sure, yeah, we're lined up on the Perseus cloud right there. All right, let's make sure that we're centered on this Perseus cloud, but it's extensive, it's massive. So I can see it's right here. So what I'm gonna do is I'm gonna bring us down a little bit. Take our telescope a little south. Pay no attention to that masked satellite zipping through the field. All right. I just want to say to everybody, if you really like this stuff, I would love to have your support. If you can support us in some way, we have a Patreon page. If you go to SkyTourLive.org, to the upper left of that page, it takes the SkyTour LiveStream, which is here, what you see here. And if you go to the upper right, you'll see the Patreon page where you can go see the different tiers. At the higher tiers, you can actually come on with us, and we will take you through. Objects that you want to see, and give you your own personal guided tour to your liking, and that's while in the middle of a stream. So people will be watching and hearing you as you'll be part of our show, part of our whole production, and we like doing that. Actually, you might have heard us. We did it for Izabela. We've got one coming up for Ronald, who is ERRT Radio, and more probably will follow. Okay, we are currently guiding. If I delay by talking about things, it's because I'm waiting for the guider to come in. I'm doing 5 things at once all the time, so it's kind of crazy. All right, so let's do a. I'm noticing we're pretty good with the wind right now. Let's try to do a 35-second shot here. All right, and hopefully we won't have to do it again. So we'll bring in the stack, and you'll see the comet from the last moment that we just did it, and we'll clear that in just a minute. But first of all, let's remove the name. You don't need that right now. Come here, you. All right, and so that's pretty cool. All right. All right. So, and this is going to be the Perseus cloud. And let's clear it now, because we're 3 seconds from the next image being read off the sensor. All right. Doesn't look like much right now. But when we start correcting and processing, oh, look at that. Now we're getting something really interesting. And we will color correct too. You'll notice that there's stuff here that looks like it's blocking the stars. Well, it is. All right, it is. In fact, I'm gonna I'm going to move this over to the left, to right about here. So I'm going to do that first. I'm going to do that now. And we'll come back to this. So let's go back to our night vision mode for just a second. And now let's bring, we're actually going to move to the west a little bit. Because we've got a beautiful dark nebula. Dark nebulae, you know, when you see all this dark dust, galaxies are full of it. It permeates the galaxies. It makes up the spiral arms of galaxies. And what you're seeing is material that was formed through many, many billions of stars dying, going supernova, exploding, and blowing their innards out to the universe. And when they do that, they actually shower the interstellar medium with everything that they were made with, and with stuff that is made when the supernova actually occurs. So it's really interesting how the supernovae work. And they're the reason that in part that our periodic table has all the elements in it that it does. They're all made in those dots that you see in there. They're all made in the hearts of stars. And when the stars die one way or another, that material comes back to the interstellar medium. That's where we came from. Carl Sagan, my favorite astronomer, said, "We are made of star stuff." And he was right. We are. We're made of stuff that was built in the nuclear furnaces of ancient stars. It's pretty impressive. All right, go back to 35 seconds here. And go to live stack and clear this last stack. This is now going to be over here. And we're going to see this whole thing here pretty soon here. These halos appear because of the system we're using. It's called a F2 system. It's very fast. Never read The Little Prince? What's that? Never read The Little Prince? Is that a story?
Yes.
Yes.
Michael Hedrick had asked a question about, let me find it.
Obviously, I haven't read it either, have I?
He said, Mark, for Daryl, do you have any trivia about The Little Prince and B612? Like where the name comes from? The author of The Little Prince, whose name I forget, I never read the book. I had to look this up. The author of The Little Prince was an airmail pilot at one time, and the serial number on the tail of his aircraft was A612. And in the story, I gather, they think The Little Prince came from an asteroid called B612, and they think he got the name from the serial number of the aircraft he flew. Learn something every day.
Yeah, interesting. Cosmic Ray gave us a definition of an Earth-based cloud, but a cloud of dust in space, of course, is what we call a dark nebula. And as Bullwinkle rightly says, this particular cloud we're looking at right now was discovered by E.E. Barnard. It's a Barnard object. I have to look up the number. Let's put this out there now. Actually, I can actually add to this. It's a dark nebula. Very pretty.
Michael Hedrick also said that he wondered if, what was it? There's also a UFO group named B612.
Oh, really?
That's what he says. I do not know. Yes, Izabela, shame on me. I never read The Little Prince.
Well, it's okay. Shame on me, too. Although it sounds familiar. Hello, Alice. Look at the detail in this showing up right now. This is pretty good. I'm going to add some enhancement now. I'm going to add a sharpening to this. So watch this. So now you can see it's starting to, it'll show more detail in it as it resolves. Space is dark, and then when you have dark stuff in space, it's like, well, how do you show the difference? It's because the stuff is not black. This is brown, and it shows, as you can see, it's brown against a much darker backdrop, and that's actually what we're looking for. We're looking to see that contrast between those. So now you can see this is where the cloud is, right here. All right, and now if I put it back to what it wants to do, this is what it really wants to be at. I'll pull this out a little bit and move this in. This is the mid-range, mid-level. This is the intersection of all the data. This is all the data on our from our cameras right here. All the data is right here. This is the yellow curve that represents the line where our data is, okay? And we're going to pull in more data. The more we pull in, the brighter it gets. If we pull the mid-levels in, then we're going to start seeing some detail that's hidden in the backdrop. And if we then pull the right side, this is the dark level. Closer we get to the peak, the darker the background becomes. If we go too far, though, then we actually will start losing our object. So we want to actually keep just to the left of the peak with our dark level, all right, like this. And then this we can adjust in or out to try and squeeze more detail out like that, or soften detail like this. So we'll put it right at around the midpoint here. And then to see what's really there, we can actually come over to this one over there and click this button right here to actually add a processing spike to everything in there so we can see what it is. So there you go. So that's what's really hidden inside of all that. Look at all this out here. This is like a hydrogen emission nebula, dark dust nebula in here. The denser stuff is darker, but look at the color. It's brown. It's brown. Okay, let's pull that out of there and just come back to a reasonable view. So we've stacked 9 of these images so far. So we've taken one, aligned it, put it on top of the other, made an image sandwich. And the more we stack, the more the dark stuff, which is data, will rise to the top of that stack. And the noise that kind of mingles with it early on is left further and further behind. Because that noise is all the stuff in between here that's averaging out and mixing together to form just sort of a bland background. And this stuff isn't a bland background. It's a detailed background. It's a detailed foreground, I should say. Up here we have a reflection nebula, which is where the dust is actually scattering the light of these stars, especially in here. And the stars have a lot of blue light because they have red, orange, yellow, green, blue, indigo, and violet. Okay, Roy G. Biv, you may have learned that. Well, the blue light is getting scattered because the dust is a very, very tiny, tiny particle of dust. And the smaller the particle, the more efficient it is at scattering or reflecting in all directions the blue light. And so these small, tiny particles are doing that right here. So I'm speaking, of course, about this area right here. Okay, inside that red square, that's the reflection nebula that we're seeing. Over here, this area is pretty dense. Okay, so you see a little dark streak in there. That's a fairly dense area. And you'll also notice, if we get rid of those, you'll also notice some interesting red stars, okay? And there's some right here. Okay, see those red stars in there? You see more right here, right? There's another one here, here. They're all throughout this nebula. How come? What are those red stars and where do they come from? Well, there's two possibilities. One, they are red dwarf stars, the small M class dwarf stars, because we have the hottest and bluest, which are the O stars, on through B, A, F, G, K, and M. M are the coolest and reddest stars. And these little red stars could be red dwarfs, which are 100 times smaller than the sun and literally 100th of as bright. Or they could just be normal stars like these out here, but buried in the cloud. Remember what I talked to you about? These stars can efficiently scatter the blue light, right? Well, if you have a star that's deep inside a dense cloud, like maybe over here, then a regular star that might be this bright right here, okay, or as bright as, say, this guy right here, all right, inside a nebula where there's lots of dust between us and the star, that star's light will be reddened by the fact that much of its blue light is being scattered in every direction. The more the light goes through, more dust, more of it's scattered. So we tend to see that stars inside these nebulae, these dark nebulae, will look red because the light is reddened by all the dust.
Mark, I have a dumb question.
You never ask dumb questions.
Is this is the Perseus dark cloud?
Mm-hmm. Yes, it is.
The same thing as the Taurus dark cloud?
I think it is, actually. It depends. I've seen that we took the Taurus. I took an image of the Taurus cloud. And let me show you here, because this was something that is.
Is this Barnard 22?
We're going to find out right now. That's where I'm going. I want to go check it out.
Izabela had asked, let me get back to where we were.
Okay.
She was looking for an object called the Little Flame Nebula in the middle of B22.
Okay. Okay, first thing we got to do is bring up and add the Deep Space catalog for Barnard objects. We'll add Barnard, these guys, and then Lynn's Bright Nebulae and Lynn's Dark Nebulae. Okay, that'll be good for now. Okay, so those will all show up. So Perseus Cloud is also known as IC 348, which is Index Catalog 348. It's Lynn's Bright Nebula 758. It's Vandenberg 19. It's also Gingrich 1. And it's, I thought, when we looked at this, let's come in closer. We might see it when we get in closer. All right, let's come over here. I want to see what the designation is. Barnard 3 is in the lower right corner of this. And Barnard 4 is just below center. Below this guy. So this is Barnard 4 right here. All right. So there's a number of Barnard objects in here for sure.
I think we're looking at a different object.
What, the one I've got right here?
No,
we're looking at the Perseus Cloud. We're looking at this right here. Is this right here?
Is that the Little Flame Nebula?
Oh, I don't know if it's a little flame. Let's I don't know anything by that name. No, this is the Perseus Cloud right here. And
okay.
that right there, okay, is this right here. Let's back out. Okay. All right, so we're actually, remember, we're over here. This is where the center is. So it's just about like this, right? So that's where that is. That's this. And so we have all this stuff here. We have Barnard 3. We have Barnard 4.
I was looking specifically for Barnard 22.
Okay.
I think we're talking about two different objects.
Well, then we can go look at that.
Carry on. I thought you were composing the mosaic for Izabela's request.
Oh, I wasn't doing the mosaic now. Sorry.
Carry on.
Okay. IC 2067 Ray says this is the Little Flame. So we can look that up as well. Is Little Flame in the Taurus dark cloud?
Yes.
Okay.
I do believe.
All right.
Izabela says the Comet, Mars, and Bernard 22 are on one line.
Okay. Hey, Desert Dweller, how are you? So that's really pretty. Now you can start to see some of the real subtleties in here, in this Perseus cloud. All right, we don't need that now. You know what it is. Let's see if we can do a little magic here. So there is the starting point, and we can pull this in, bring it in. Look at that. There's so much going on in there, Daryl. Yeah, and let's see what else we got. We got a lot going on in there. Okay, so what we're going to do is we're going to call this what it is. It's the Perseus cloud, PER cloud. And we're going to call it a DN for Dark Nebula. All right, and we'll save it. This is 23 exposures. And when we say we're saving it, where is it going? It's going up to our server, which you have access to by going to skytourlive.org and scrolling down, and it'll say, take me to some cool pictures. And you read the instructions there, and you go there, and you'll get the directory structure, and you just go down, and you'll get these objects that are saved just like you see them here. So, for instance, this object, if you go to our database, or our server online, this object will appear just like this. This is exactly what you'll see up there, because that's what's saved. And you're free to download that and do what you like with it. All right? You just can't sell it. Not that you would. But if you're interested in better shots, then what we can do for you is make up a beautiful photo for you and make it available to you. All right, so Sylvanira Severina, how are you? Nice to see you. Okay, all right. So now let's now that we've done this, we'll clear it as we saved
Mark,
it. Yeah.
I'm going to drop an image in your chat.
Okay.
Give me just a second.
No problem. That's really pretty. All right. And back to doing our night vision mode. And now let's see if we can do B22. Let's find out where that is relative to this. It's right near. See that? It's right near Mars. So we'll go to the Taurus dark cloud now. And
I just dropped the image that Izabela sent this morning into your chat.
okay.
It may help you as a reference.
All right. Because we're just a little bit below it. We're not too far away. Now, for people who want to say, well, why not look at Mars? We could look at Mars, and we have. But keep in mind, this is a wide field telescope. It's a wide field system. And it's one of these systems that is, it's got a big field. So Mars is a tiny planet. So this is not the best telescope system to observe planets with. All right. But that's unfortunately the case for us right now. All right. So, and this guy right here, is that the little flame?
Yes.
Okay, so the little flame should technically be in our view right now. Let's.
I do believe.
All right. I bet you're right. Let's just do a 20-second shot just to see what we got. Okay. Okay, we'll do this.
Sure is dark.
Yeah, let me just get us down a little more here. Okay, there's the streaks of the cloud that I'm familiar with. And that's the Taurus dark cloud. Look at those. Those look like clouds getting in the way, but they're not. Alright, and there is the little guy we're talking about down at the bottom. So,
Okay.
knowing that, what I'm going to do is bring that up into... I thought it was right nearby. I just wasn't quite sure. This is going to be a really pretty picture. This image is going to look ghostly, guys. It's going to look ghostly. So when you look at it, you're going to say, wow, it is pretty ghostly. I should have dumped this earlier, so this is good. All right. So now we're going to bring it up. And I'm not going to go too high, because if we're going to do a mosaic, I don't want to lose too much of it over the top. But it's right there. So let's start here. Let's let this catch up. Let's do our guiding. I'm actually going to move a little to the west, actually. Okay. Might be a little too much to the west. It's right there, and that's going to be in the lower right. Should be okay, because there's a lot here right now that you can't see. And then we'll go down and we'll pick up more. All right, so we're going to do a 35-second shot at 350. All right. And there we go, we're on our way. Now we'll do our live stack here. And the live stack, get rid of that. So you can see this is the previous shot, and we're going to be pulling this up into the middle here. So we'll clear it now, and that'll be higher, probably over here somewhere. Let's find out. I kind of move things around. Hello, Satisfying Animations. How's it going, man? Sam S. I don't know if I said hi to you, but hi there. Alright, let's do this properly here. Look at that. So there is this beautiful little nebula. This is the Taurus. The beginning is the Taurus cloud. It goes way down below me. So we can actually do a kind of a mosaic. Izabela had asked, and Izabela, you get your wish. We'll make an animation for you. Not an animation, a mosaic. Hello, Jane Murdoch. How are you doing? This is our Seagull Nebula tumbler that we have. Be available soon enough to everybody, along with blankets and jackets, and oh my god, it's just crazy. There's so much that we can do here now. Alright, let's darken this up, get some detail. Look at that. What I love about this set of objects here, the Taurus cloud, is that this looks almost unearthly. Well, it is unearthly, hello. It looks almost wisp-like, gossamer. It's just amazing when you see it processed. So we'll be doing this and getting it processed done. Izabela's going to turn it into a mosaic probably before we even get off the air. She'll have it done, I'm sure. Hello, Ralph Wooden. How are you doing? Excellent. I'm glad. Glad you're doing good. Nice to see you, Ralph. Thank you for coming, hanging out with us. It's always nice. Sylvania, I speak some Spanish, but I don't know coloca. I don't know what that is. And you're saying, how come something... Are you saying, how come you don't see emojis? How come you can't write emojis? That might be what you're saying. I don't know. I don't know how people are making the emojis, to be honest. Okay, let's darken up some more. Oh, look at that. You can clearly see a cloud blocking the stars behind. You see that? It's really just gorgeous. Satisfying animation says, been so cloudy in Ontario. It's been months since we went outside the image. I can understand you. Okay, it's Portuguese. Christina says, I think she's asking how to use or make emojis on a PC. Oh, okay. I don't know how people are doing it because I'm usually doing the stream. I'm not in the chat. Thank you, Christina. Gracias para su ayudar.
If you click on the little smiley face at the bottom left of the chat box,
yeah, there's some chatty things there.
An array of emojis will come up. If you type one that's common enough, you just type it and it'll come up.
Yeah, Daryl's right. I see him now. Okay, very cool.
Mark, excuse me one moment, please.
Sure. So what we're waiting for every time while we're waiting here, we're actually stacking. And if you look right here, it says that we've stacked 8 images so far. All right. And this yellow bar over there is the progress bar. All right, that shows us right there. Sorry. This progress bar shows us how far along we are into the next image to put in our stack. And again, we're just stacking them on top of each other to make all the subtle data come to the top. And it also, the more you stack, the better the color gets. If you notice, this was sort of a dark blob. Now it's showing differences in color, isn't it? Isn't that amazing? Oh, it's just incredible. This is good music for this one, too. Izabela, this is the nebula that you wanted to see? That is the, is that the little flame? Is that what you're talking about? Is that this guy right here? Let me know. I'm gonna guess yes. Actually, Satisfying Animations asked about doing longer stack times. When I'm doing a private session for myself or for someone, we'll go several minutes, but I don't do 2 hours because there's a point of diminishing returns, and I don't want to reach the point of diminishing returns, you know. Okay, so let's look here and go back to this guy. That's a Taurus dark cloud there, yep. And let's roll out of it. Go to here. Okay.
Back.
Yeah, I heard. Okay. All right, this is the little flame that you were asking for before. And okay, that's really pretty. That's gonna look nice. It's already looking nice. It'll get better. Okay. So back here, look at the huge difference between the stellar background and this nebula. That's pretty impressive. Let's color correct and see if that helps us. Oh yeah, look at that. Okay, now, by color correcting, you actually see this brownish dust stands out. Now it's almost 3D, isn't it? You know, sticking out like a sore thumb against the backdrop. Just beautiful. Wow. Let's see what else is in here. Let's pull this up. See that? There's a lot of detail in here. You have to pull, well, I mean, it's in there. It's buried in there already. And we'll pull it out. But this beautiful gossamer session was interrupted. Okay, don't know why, but we'll get it back. Okay. All right. So as I was saying, this beautiful gossamer cloud has such detail in it that we're going to pull all that detail out. We're going to be moving down here. We've stacked 16 of these so far, and we'll go to 17, and then we'll move down. But man, this is just beautiful, and we can darken things up and increase the contrast. Look at that. Isn't that impressive how much stuff there is in here? Unbelievable. I know, it's just crazy. Alright, we'll kill this over here now. Drop it down. Look at that. And then we're going to drop down to get the rest of it. And then the universe is filled with all kinds of this stuff out there, you know. So it's just something. It's amazing. There's going to be another star down here that we're going to see shortly. But we're at 18 now, so we're going to pause it here, and we're going to change this to the Taurus cloud, dark cloud, and that includes the little flame nebula. And now we'll save the little flame and Taurus dark cloud, and then save it exactly as seen. Okay. All right. Now we'll clear. Go to our night vision mode. And when we get to the night vision mode, we'll move us down to do our thing. All right. All right. So what we're going to do is we're going to move this star, or this star I should say, up to about there. And that will do it. You can see the little flame. Okay, there's the other star coming in. That's actually Mars, I think. That's probably Mars. Interesting, we'll have Mars in here. Okay, and then we're going to move over to the east some more. Get the rest of the cloud. Yeah, this will be Mars.
If that's not Mars, we're all in trouble.
No, it's Mars. I'm pretty sure it's Mars. All right, and now we'll do our 35-second setup here again. And of course, Mars will be blown out, but we're not looking to get Mars. Okay, we started the guide. We're going to get the rest of the Perseus cloud. Yeah. Cosmic Ray. Photobomb by Mars. You're absolutely right, man. Photobomb by Mars. Alright, so let's get out of this and go into our stack. We're underway now.
Actually, I think Mars was part of the idea behind Izabela's mosaic request.
Maybe so.
She wanted to try to catch from the Comet on the left to Mars to the Taurus Dark Nebula and the little flame on the right.
Well, let's see. From where we are. From where we are down here. Alright, actually right about here. Tomorrow night's going to be the night to capture all that, because the comet's not. The comet's still far enough away that we'd have to go a little pretty far out here to catch the comet. So we'll wait on that, but that's okay. We'll do it.
Did you see the image I dropped in your chat?
Not yet. I'm just. My hands have been full here. 35 seconds.
That's okay. My brain is full.
I just looked at it. Yeah, that's right. All right, let's see this. Let's get our first image here. Yeah, see, I told you. Yeehaw! Look how bright Mars is. It looks like a supernova. So, getting them all together would require a special tool called an occulting disk. So this is the Taurus cloud here. And let's see if we can... So there's the Taurus cloud. There's a little flame. Here's the rest of the Taurus cloud. But Mars is so bright that it's causing multiple artifacts in here.
Ooh-wee.
Mm-hmm. See that, Izabela? So there we go.
Well, it was a good idea.
Yeah, it was. Good night, Daisy and Zoe. Thank you for coming. I know you got to get up early tomorrow. Thank you for spending some time with us. Well, we'll give it a shot. Just a little longer, see what we get. We're going to get a lot of secondary reflections that are going to look like nebulae, like this right here. That's a lens flare, an internal lens reflection, which you're going to get with any bright light. This is an artifact of the cables, because our camera's actually on the front of the telescope. So this shot, Izabela, won't be worth much. So maybe we should just stop, because we're not going to be able to see it. I mean, the whole shot is taken up by this blown out Mars image.
Yeah. Ray, what you're seeing there, that's an artifact of the hyperstar. system on the telescope. It tends to make halos around bright objects.
Yeah, with this black thing you're talking, if that's what you're talking about, Ray, those are the cables, because they come out of the camera at the top of the telescope and go sideways across the top of the telescope. All right. Well, just to have a record of it, I'm saving it, just like we see it, just to have a record of it. And then I'm going to get out of it because it doesn't appear that it's going to be worth taking a picture of, unfortunately. Mars is just too bright. Alright, so let's go back and look at something else that might be in the area. There is so many objects in here. It's almost like we didn't have to go that far down into or sorry, we didn't have to go down to Mars. We could have gone to a area to the right or to the left, but that's all right. I figure while we're here, let's go check out something else. It doesn't have to be this. Actually, there's something else that I think would be looking really nice right now. Okay, and that is, there it is. Let's see where this is. Yeah, I thought it was in the area. Yeah, it's right near the California Nebula. Okay, so why don't we check this out. This is the Northern Trifid. This is a beautiful emission nebula that actually has dark nebulae associated with it. It's just spectacular. There it is. And we'll find our way into that. The wind is held off, which is really nice. Alright, so let's go to the west a little bit. And go south.
Mark, Ralph Wood wants to know what filter you're using.
Oh yeah, the filter we're using, Ralph. Again, you know, I would ideally like to be using what are called narrowband filters, where I'm doing the H alpha, the oxygen 3, and the sulfur 2. All right, but those you take with a monochrome camera, and then you combine them and make an image later. So I'm using a one-shot color camera that does basically those 3 band passes approximately in one shot. And so that filter is one called the UHC-S. All right. If you look at the band passes, there's some differences, but it gives you the approximate same thing as using the combined version of 3 narrowband filters effectively. As you can see, I mean, when we shoot in the full moon, we capture faint nebulae even with the full moon out. It's nice to not have to care too much about the full moon. Well, we still do, but we don't have to. All right, I'm going to do a focus run again. Okay, that's out of focus now. And now what we'll do is come in and do a scan here. This is how we focus. This is the autofocus system in operation. So we're doing samplings of stars, and we're finding the best settings that makes the star image the smallest in the view. Right? And it's going to build a curve down here, which you'll see. Right? And that curve is going to have a parabola in it. And that parabola is going to have as its central focus All right, so when this curve comes down, it's going to make a curve, all right, like this, all right, and right in the middle is going to be a line, and that line is going to be the spot where the best focus position is. So it's going to build a line of best fit through these values and make our central focus perfect. Lucy Clark says we have snowy sky tonight, northwestern British Columbia. Oh man, I'm sorry to hear that. Unless you like snow. So we're going through here. We're going down. Here's our curve. You can see the average curve coming, and as this goes back out of focus, it came down into focus and out. It'll find the curve of best fit. Now it's bumpy right here because we have wind affecting us, but it still does a best fit curve and finds the best position, regardless. And it's doing more shots here to find the best focus, and it found it. So now we're going to click here, best focus, right? And when we hit best focus, it's going to allow us to move our focusing all the way to the back and all the way to the front, and it's going to move right to that center. There it goes. And now you see the stars are pinpoints like they should be. So the focuser has done its job, and we can get rid of it, and now we can start a beautiful 35-second shot of the northern Trifid at 350 gain. All right, and we're underway, as you can see by the progress bar down there in the corner, right here. I think you see what I'm talking about, right, with the progress bar. But in case you don't, it's this guy right here. That yellow bar. Just watch that moving. Alright, so we're going to go into our live stack now. And we're going to clear the last one. We have 2 seconds left, and now you'll see the beginnings of a beautiful photograph. Look at that. Very nice. Very nice. All right. That's really pretty. We'll just move this up a little bit. Look at that. So, as you can see, the northern Trifid Nebula, called so, and see now we get another one comes in. It looks much better all of a sudden. That's how stacking works. All right, so we have 2 stacked, and it's twice as good. When we look at this, you'll see that this object here, there's something blocking the stars behind it. It's all this dust which is blocking it, and we'll see it. We'll see it as we get better, as we get more coming in here. And then if we try to really push it a bit, we can start to see the dust come out. All right, and that's kind of too much, so we have to let it catch up. All right. We will be going back to the Comet shortly as well, just to check on it. Jose Santos, hello, how are you?
California while you're in the neighborhood?
I guess we could. It's right nearby.
Yeah.
Jose Santos says, thank you for how much you give and share it, everybody. You're more than welcome, Jose. This is great. Astronomy is, of course, not just a passion of mine. It's my career. So I do what I can to pass it along, right? So you're more than welcome. And thank you for joining us, Jose. Where are you from? Why don't folks tell us where you're from? I know where many of you are from, but from the new faces, I don't know. And while we're waiting for this to come in, one more thing I'd just like to do real quick is to just point out the basics here. Some of you have seen this already. This is the telescope control section over here. This is the telescope computer. This is the view inside the building 2,500 miles away from here out in the building in Arizona. This is me. I don't need to put a square around me, but if you want me to, I will. Okay. And when we're stacking, this is our stacking screen right here. This shows all the data of our stacked images. This here is the camera control cluster. All right here. And this is our focusing system down here. And then we have some other imaging stuff down here. So these are all very important sections, and you can't do without any of them. Okay, so that's good. All right, and again, as before, the most important things in the camera control is the exposure, how long we're gonna be exposing on this sensor, and the gain, how sensitive we want the sensor to be. All right, so as you can see, we're at 35 seconds on there, and our gain is 350. The gain goes to about 600, so we're not even halfway there. Well, we are halfway there. We're just over halfway there, I meant. So, but as you can see, the higher the gain, the more the noise shows up. So we're trying to mitigate that, trying to make that less. As you notice here, let's zoom in on this now, because now that we've taken in, we've got 8 images. Look at this beautiful, beautiful Northern Trifid Nebula. Why is it called the Northern Trifid? Because it has these dark lanes which divide it into 3 segments. 1, 2, 3. Kind of like the Trifid Nebula or the Trifid Nebula that we see in the summertime. And again, we see those red stars buried in the darkness. They're light reddened by this dark dust that's in here. So that's probably why they look red. They might be normal brightness stars, but when seen through all that dust, the light is reddened.
Mark, Cosmic Ray asked me a question.
Yeah.
That I think he meant to ask you, because I haven't got a clue what he's talking about.
What did he ask? I'm sorry, I didn't see it.
Daryl, how long did you work with ZWO to understand the A to D conversion in the camera, its interaction with Hyperstar, and sharp cap image presentation?
Well, I would dare say you probably haven't done a whole lot of that at all.
Well, that's my point, exactly.
Well,
I told him you're asking the wrong guy.
That's all right.
Which was why I asked you.
All right, well, Ray, if you look up the ZWO ASI 294 MC Pro camera, you can look up all the technical specs. You can see the noise of the camera at different temperatures. You can see the information, the analog to digital information that you're talking about, or anything else you need to look at. It's up there. So the technical specs of the camera will tell you what you're asking me, which I'm not prepared to go through right now, because like I said, I'm doing 5 different things, and I don't want to start doing things half well. There we go. I know that's really not the answer you were seeking, Ray, so sorry. However, to be honest, I have worked with Simon at ZWO pretty extensively over the last several months to work out issues with the cameras and figure out amplifier noise, because we have amplifier noise over on the left side. And we're thinking about getting another camera that doesn't have any amplifier glow at all. But we process it out. It's not like we can't get rid of it, you know. Look at this, though. Now you're starting to see all this convoluted knots of cloudy, dark dust mixed with this emission nebula. See that? That's really pretty, Daryl.
Ray, I just said that because I'm familiar with it. Or are you just trying to poke me in the eye?
Oh, if you're talking about the halo around Mars, that doesn't really have anything to do with the ZWO camera. That has to do with the optical train, the optical system. And it's the result of multiple internal reflections on an f2 system. You know, the shorter the focal length of the lens, the more light it's gathering, and the more that bright light will cause these extra rings like that. And the number of rings is the result of how many bounces the light goes through and how many lens elements it's passing through. So it has nothing to do with the camera. The camera that's all happened before it even gets to the camera. Ben Zavella, how are you? Nice to see you. We're doing well here. I think we're having a fun time. Check this out. This is the Northern Trifid, man. And if you need to see that, well, here it is. Put that right out there for you. That's pretty. We've done 16 of these. After improving the guiding capability of the telescope recently, I've actually been able to take much longer exposures. But the problem is that, you know, I'm not going to make you guys sit and wade through a 10-minute exposure, you know, and then you got to do that 20 times. 200 minutes? No. We're seeing different things, and we're getting more than enough detail in them. Look at this. This is just beautiful. Hello, Gabrielle F. How are you? Nice to see you. Yeah, Cosmic Ray. That's, again, it's the F2 system that's causing it, you know. I brought this up with the Hyperstar guys. Again, you got to keep in mind, that telescope you see up there is the only one on the planet that has a Hyperstar on it for this particular telescope. They don't make them. This was a prototype. So we actually have a prototype system that we had them develop for us. All right. So maybe those rings could be lessened with some better design. I'm not sure. But it's doing the best it can for a system that was an f8 10-inch telescope. This was an f8 10-inch, and now it's an f2 10-inch telescope. So we're actually, like, what, 530 millimeter focal length on this now? Is that what it works out to be? It's just crazy. We're 25 times faster than the f8 was. The native telescope out of the box was 25 times slower than what we've got now. So multiply all the times when we do, like, this is 35 seconds. Multiply that by 25, and then we get the approximate image that we got earlier. See? So, you know, I was thinking of you. I was thinking of all of you. I wanted to make sure that you had an experience. No one's doing this. No one is doing what we're doing. Capturing deep sky objects like this. This is the only stream I've ever seen on YouTube where people are capturing object after object after object and making them available free on a server. I don't think anyone's doing that ever out there. I haven't seen it. You know, and you want the objects? Go to SkyTourLive.org. Scroll down to the Give Me Cool Objects. You know, go to the upper left, you get to the stream. Go to the upper right, you get to the Patreon, where you can pick a tier and support us monthly. But on SkyTourLive.org, you scroll down and you can go to the cool pictures, dig in, and see this object just like you're seeing it here, seconds after we take it. You know, so that's pretty cool. So I'm going to actually, since we have 21 of these, I am going to save it.
I have a question for you when you
Sure.
have a second.
Go ahead.
From F8 to F2, something inside me would think whatever the difference is would be an even number. Where do you get 25 at?
Well, that's the value provided to me from Starizona. I didn't actually calculate. I haven't done an f8 to f2 comparison with this telescope directly. They say 25 times, but they're also basing it on the fact that this was originally, the Hyperstar was originally made for Celestron systems. And so they weren't like f8s, they were like f10s, I think. And like the 14, I think, was like an f11. You know?
The C14.
I thought it was.
Yes, I believe it is.
And so they figured 25 times. So that's sort of like an average,
Okay.
from what I understand. Now, it might not be 25. It might be 26. It might be 24, but it's going to be, some multiple that's equally as impressive.
Okay, thank you.
Sure. Gabriel.
You'd be talking like towers or something.
Oh, yeah, no. It's a 25 times faster. Okay, kind of a thing. So it's capturing things 25 times faster. At the F2 level, especially considering that we don't have a secondary in here anymore. Cindy Murphy says, "Great people. I'm a toddler. They are rocket scientists, but I'm comfortable." Are you talking about? What are you talking about, Cindy? What group are you talking about? Unless you're talking about us, I couldn't tell. I kind of... Uh-oh. Izabela says to Bonnie, "Have you noticed that Mark hasn't told us stories for a long time? I miss the stories about the box, the fox, the..." Yeah. I don't want to repeat the stories, though, and I don't make them up. So when I tell them, I tell them. If I think of them, I will tell you, to be honest. I will tell the space box story really fast because that was really cool. It's what got me into astronomy. And when I was 9, remember I told you I wanted to be an astronomer? Well, I had just had a big surgery and I had to stay home for a full month. Oh, thanks, Ray. Raymond's with us. Hey, Raymond Bobel. Great to see you. Oh, no problem, man. I sent Raymond some 3D printed craters because he was extremely generous to us. Thank you, man. But I knew at age 9 that I was going to be an astronomer, and so I did a space station plan, and I sent that space station to NASA. I did it on notebook paper that I tore out of a notebook, single sheets. Sent it to NASA. A NASA scientist reviewed it, sent it back to me, and he had looked at every page, made check marks, wrote in, suggestions and stuff. It said, "Great idea." Oh, as a 9-year-old, that's like, "Wow, good idea," he said. Well, anyway, in that same package was a big giant box, which I called, as Izabela was suggesting, the space box, my space box, because this scientist at NASA, he packed it full of models and books. It was a big giant box, filled to the brim, filled to the top, with mission patches, cloth mission patches from the Apollo program, the Gemini program, the Mercury program. And then he filled it with plastic model kits from the gift shop. And it turns out he probably bought them with his own money. That's my guess. And then they put brochures, everything under the sun about what NASA does. This guy must have had a blast filling this box. Well, he sent it to me, and little did he know that he was going to make this 9-year-old decide, first and foremost, that he was going to not ever waver and he will become an astronomer, and that's what I did. Now,
I have heard this story before. Who was this gentleman? Because he was famous, wasn't he?
Yeah, he still is. It took me 40 years, but I finally contacted him and said, "You're the guy that is responsible for me being an astronomer." And he laughed, and he just thought it was the coolest story. He did not remember that little kid that sent him a notebook paper space station plan. I even had room for pigs and goats. on the space station, by the way, and cows for milk. Okay, and I even dealt with carbon dioxide because I had known about how the Apollo mission had to worry about scrubbing carbon dioxide and how they did it, because I had read all that, and so I put that in there as a safety thing. And in case we need to do this, let's make a charcoal filter to scrub carbon dioxide. And he thought he was tickled by that. He thought that was the coolest thing, because it was, of course, what they did. But I read it anyway. This guy is or was, he just retired, the head of all remote robotic missions to the planets. He's responsible for the Curiosity rover, the Perseverance rover, the New Horizons probe, the Dawn probe. He's responsible for Cassini and Galileo. That was on his watch. The man's name was Burt Lee. Gentry was his nickname, Burt Gentry Lee. And Gentry Lee works at Jet Propulsion Laboratory. And I will be in Pasadena, where Jet Propulsion Laboratory is located, in just 2 weeks. And I'm really excited to think about taking a side trip to go and see this guy for the first time. I think that'd be pretty cool.
It would be cool.
Yeah. But Gentry Lee was my hero, because he was a scientist at NASA when he started. And he said to me, he goes, I told him about the space box. He goes, oh my gosh. He goes, that would be me. I would have done that. I said, you did do that. You did do that, and you knocked me for a loop, and as a result, you got me so engaged into this whole science that I never looked back. I'm sort of like, well, that could be good, that could be bad. Well, yeah. Look at this. Let me zoom in some more here. This is really pretty. Look at that. Oh my gosh. So let's see if we can. So that's really pretty. Now we can actually pull it back until we start to get some data. Wow. So there, Izabela. There's your story again, which I think is great. I mean, I like telling that story. Wow. Okay. This is plenty of these. So we'll pull out the name tag. We don't need that right now. All right. And we'll say save this as Northern Trifid. That's going to make a beautiful image. Thank you, Lucy. And we'll save it exactly as seen as well. Now, a kind of mischievous story is one that takes me back to my childhood, because I was investigating how to make hydrogen gas, because I was very interested in the Hindenburg and the first element in our periodic table. At the time, I think I was 10 for this one, and so I went to the books at the library, and asked Mrs. Brown, the librarian, if I could go into the adult section. And she said, well, why, Marky? I said, I want to take out all the books on chemistry that I can. And she says, oh, well, those books are written for at least high school. And I went, that's okay. I want to look at them. And so I got an adult library card at age 10. And I had to be escorted to go up into there. And I thought that was actually pretty cool. It'd be up in this giant bookshelves when they had the little bookshelves down in the kids section. And she let me take out books on chemistry, and I took them home and I started looking up the reactions. Most of it I did not understand at the time. However, some of it made a great deal of sense. And I learned that I could use sodium hydroxide and mix it with a catalyst, like water, to actually help it along, and then have some metal shavings in there for this stuff to actually operate on as a strong base, as I had learned. And I'd get hydrogen gas and water vapor out of that. And I looked at the formula, NaOH, sodium and 0 and the O and the H, sodium hydroxide, okay? And I figured, all right, well, this is going to be cool. So I created a hydrogen still in my backyard. I got a big glass water jug. I'm preparing to go to the next object, by the way. So I got a big glass water jug, like they have for the old water coolers. And this glass water jug I filled with metal shavings, water, and I went into the house and I said, "Ma, do we have any Drano?" "Yes, we have some Drano under the sink." I said, "Okay, I'm going to take some." "Well, don't take it all." I took the entire bottle of Drano and I poured the whole thing into this container. Brought it back with like one little piece in there, one little thing. I didn't use it all. I'm waiting. And this, we're having a slowdown here. The timer has stopped, so we're waiting for it to reacquire. So I actually ended up creating this hydrogen still, and the water started to boil, and that glass jar got so hot you couldn't touch it. And when I actually, let me try something here. When I actually ended up, looking at what was coming out of the top of that jar, it was a hot gas mixed with water vapor. So I went down to my dad's laundromat that he owned and said, "Dad, can I have some clothing bags?" You know, the really, really thin plastic clothing bags. And he said, "Well, what do you want them for?" I said, "I'm doing an experiment." "All right, well, you can have like 2 or 3. All right. I took like 10 or 12. Okay. Ran home on my bicycle, which wasn't that far away. Okay. And when I did, I actually took the clothing bags and I clamped them over the top of the output of the bottle. And this gas filled up this bag. But it was full of water. So the bags would float, but kind of barely. So it was hydrogen mixed with water vapor. So I went in the house. I said, "Ma, do you have any milk?" "Sure, it's in the refrigerator." So I poured it down the sink and took the jug. "Ma, do you have any cotton?" "What? Yes." "Okay, I need some cotton. It's in the bathroom. Don't take it all." I took it all. I stuffed it inside the jug. Okay. Went outside, put the hose up inside the container. Now the water vapor was going into the cotton. And the water vapor was going to condense on the cotton. I don't know how I thought this would work, but apparently it did. And then I ended up going and waiting about 4 hours, and that's how long it took for this stuff to fill this bag. But it was dry and it was hydrogen, and I made up this hydrogen balloon, and I ended up taking it and over to the schoolyard after it filled up, and I tied it down to the ground, and I shot a flaming arrow at it. And I waited 5 hours for this. And the resulting boom was nothing short of spectacular. I was like, yes! It was like, boom! I could feel the heat for a split second. And then you saw this little, it was like a mushroom cloud of black soot from the plastic being vaporized going up. Like, yeah! And it rattled windows in a neighbor's area, just neighborhood near me. And so they ended up calling the police. Something exploded in the neighborhood, and I ran back to the house. And I see the police come by and smile, "Hi." And they go by. I had no idea it was me. They never found out. Well, maybe until tonight. We're going to the California Nebula.
See, a scientist would have released the balloon and watched it fly away, and maybe timed it or triangulated on it or something, but the kid had to shoot it with fire.
Look, I was a kid, inquisitive, and to be honest, I needed to understand why the Hindenburg blew up. So I needed hydrogen to understand that. So that's what that was about. I had to figure out, why did the Hindenburg blow up the way it did? And I figured it out. And there's the beautiful California nebula. I'm gonna kind of drop it in and bring it up. But
Oh, the humanity.
oh, the humanity, yeah. But the fact was, when I saw the Hindenburg blow up, I was amazed to see people running out of the wreckage. It's like people survived in there. How did they do that? And I said, was it not that hot? And I said, now I have to have an experiment. I got to make a hydrogen balloon and feel this heat for myself. So I felt the heat. I also singed my eyebrows and my hair, actually, in one of the episodes. But my mother got mad at me for that. What happened to you? Nothing, Ma. Were you playing with matches? No. I wasn't. I wasn't playing with matches. I didn't lie. So anyway, so the bottom line is, I did this probably for one full summer, and every 5-6 hours, usually in the afternoon, the neighbors would be treated to a boom that they'd hear in the neighborhood, not knowing quite what it was, and me never owning up to it. But they called the police almost every time, and every time the police came through the neighborhood, and they just kept seeing this one kid on the side of the road like this. I didn't have a mustache.
One of our uncles taught us how to generate acetylene gas.
There you go. That's dangerous.
Oh, yeah.
So what ended up happening was I had one or two balloons get away, and I was really, really upset because it took 5 hours for these to fill. You know, counting for loss and osmosis through the thin plastic. And so I stopped doing it because I was getting too mad at the fact that they were just flying away. I had, again, 2 of them. So anyway, that was the hydrogen balloon episodes. And let me tell you, I learned a lot about chemistry. And then my mother and father bought me a chemistry set when I started telling them I like chemistry. That almost blew up the house. Well, burned the house down, I should say. Not blew it up. Because I made my own gunpowder. At the time, the chemistry set you got... Okay, we're guiding. I can do this. The chemistry set you got was actually full of all kinds of stuff that you'd never find in a chemistry set today. And I was so impressed with my chemistry set. It was in a metal cabinet. It was a metal cabinet that you opened up. And there they were, and I'd surround myself with them going, ooh, ooh, phosphorus, magnesium, oh, sodium metal. Let's put that in water. Oh my gosh. And it was just crazy. I mean, you had all that stuff. It was all in there, you know? Okay, here's the California Nebula. This is a beautiful emission nebula. Oh, I mean, holy crap, look at that. That is beautiful. Let's pull this out of there. And let's actually move the telescope out of the way briefly. All right, and check this out. All right, and we'll go to full screen on this. And watch what happens as we get the second stacked item. You'll watch this get much clearer. You ready? Here it comes, watch. Here it comes. Look at that. Ah, it's getting better and better. Look at me, I'm on fire. It's fire off my head. Wow, that's pretty cool. You know, I love it. So this is really cool. Really cool. All right. So the chemistry set was fun because I actually ended up creating a concoction. And I noticed that when I produced a flame, Daryl, okay, I had a Bunsen burner too. So I heated it from the bottom. I guess that probably wasn't a good idea. So I ended up, I don't know how it really worked out because I don't quite remember all of it. But what happened was I lit it from the bottom, and then they put a match in the top. And that's sort of the last thing I remember, because what happened next was there was a loud pop, and it wasn't just the hydrogen in the test tube. There was something else going on, because the test tube was obliterated. It was gone. And there was a loud explosion kind of sound in my ears anyway. It probably wasn't that loud. And I saw something go up. And I ended up looking up after the smoke cleared. There was a lot of smoke in my room. I had to do this, open the windows, because my mother was going to start yelling. It smelled foul. And on the ceiling was this seething brown mass stuck to the ceiling. Like, and was going like this. I didn't know what it was doing. No, it wasn't alive, of course, but it was just sort of like going and dripping down. Some of it fell onto the floor. That was stained it permanently. So I looked up at the ceiling and went, what do I do? And I got on the chair, and of course did what any kid would do. I grabbed it with my hands, scooped it off the ceiling, and threw it onto my wooden table. And I looked at my hands, and they were stained red and blue. Okay, that didn't come off for like 2 weeks. All right, it was just really bad. I mean, I put methylene blue in there. I mean, that's inert. That doesn't do anything. But I wanted color. Well, anyway, whatever I generated, whatever gas I generated, it made quite a pronounced noise. You know. MLR says, I think we all had that set in the 70s. It's amazing we survived. I agree with you. You know. Like I said, I almost blew up my room, which I thought was kind of funny. Well, not at the time. And when my mother smelled my room after, because I got all the smoke out of the room, but she smelled the room and said, "What did you do in here?" You know, nothing, Ma. It's the chemistry set. There's sulfur in the chemistry set, and that's what you're smelling. And she sort of, I wasn't really lying, because I did put a copious amount of sulfur in the test tube. I don't know, Daryl. I think I made some kind of volcanic compound.
Maybe you were vulcanizing rubber.
I think, yeah, maybe. I don't know. I'll never know.
Can you zoom out just a little bit and show the bright star down at the bottom?
Yeah.
That's Menkhib. That's what's lighting up the nebula.
Yeah, that's what's neat about this. Menkhib is at the exact bottom. Okay. I've said this before about the California. This is the California Nebula, by the way. But I've said this before. If you look at Menkhib down here, you notice this arc. This is an arc. You notice it sort of radially lines up with Menkhib. Well, Menkhib is responsible for ionizing the hydrogen gas in here, causing it to glow. But Menkhib also has a very, very powerful stellar wind. If I recall, Menkhib's like an O star, isn't it?
I believe
It's
so.
It's one of the hottest and bluest stars there is.
Just a second.
Much of the energy of these stars is given off in
Yeah.
ultraviolet energy, in the ultraviolet range.
It's an 07.53.
Yeah.
It's about 200 and... Where is it? 263,000 times as bright as the sun.
Yeah. And most of its energy comes off in the ultraviolet, okay? And if you look at this arc, Menkhib also has very, very powerful stellar winds that push stuff off. So when you look at this object here, you're seeing this stellar wind is actually causing this shape here in all likelihood. All right, now we don't see it in 3D, so we can't really say specifically what the exact shape is, right? But we do know that Menkhib is very powerful, and so it is responsible for shaping this nebula to some degree, without a doubt. So that's pretty cool. Well, that's the Menkhib. That's the Menkhib enigma, right?
According to Wiki, which you should take with a grain of salt, Menkhib is actually a little bit farther away from us than the nebula is.
Yeah. We talked about that too.
The nebula is about 1,000 Menkhib's about 1,200 light years away.
Right. So what we're missing is the possibility that this far side here on the nebula, this far side of the nebula might actually be stuff that's pushed out by Menkhib. And maybe this entire thing is a hemispherical bubble that Menkhib is actually pushing out of gas. Now, it didn't come from Menkhib, but it was an existent hydrogen region in here. And this is light years. So clearly, these stars are very powerful. You know, and they can affect light years distant. You know, that's what's very interesting about these. Yeah.
Excuse me just a second.
Sure. So let's bring back the telescope here. And there we go. You can see where the telescope's pointing off in that direction. That's actually toward the northwest. North is directly out the back of the building, so the north is that way in the building. East is that way. West is that way, and south is directly. We're looking from the south here. Isn't this beautiful, guys? It is really pretty. So just so you know, that's what we're looking at. California Nebula. Let's bring up our stack. And let's see if we can do a little work on the stack here. We're going to dock it back at the bottom here. And let's see if we can subdue the colors a little bit. Not much, just a little. There's this one beautiful little dark nebula in here, which is really neat. There's more over here and here and here, but this is the most interesting one. California Dreamin'. No, California Nebula. Alright, so this is 18 stacked, so we're going to save this here. Save exactly as seen. Again, you can go to skytourlive.org. Since we just saved those, they'll be up there in probably 25-30 seconds. Maybe a little more, a little less. And if you notice inside in the chat, Izabela is putting up links and telling you where you can go to things like the Patreon. And I think you've done the database tonight, yes? Cosmic Ray says, so how redshifted was that hydrogen explosion? And that's how you know hydrogen spectra is red. No, the hydrogen spectrum actually it's not that. I'm not sure which explosion you're talking about, but when you ionize hydrogen, when you knock the electron out of the hydrogen atom, it's just a proton for a period of time. And the electrons gained energy to go higher in a higher orbital state, a higher orbital energy. And finally, you can actually knock it loose from the atom entirely, so it's just a nucleus. And then that electron could collide with other particles out there, and then finally it can drop back into the atom. And when it drops back into the atom, the reason it drops back into the atom is it's shedding energy. So when it sheds energy and gives off energy, that energy comes off in the form of light. And it drops into multiple levels within the atom, okay? The electrons can drop into a variety of levels, but most of them in hydrogen drop to the n equals 2 level. So it dropped to the second level in the hydrogen atom. That second level, that drop, that cascading fall to the n equals 2 level generates a red light like you see here. And that's the color of ionized hydrogen, all right, is the red. We call it hydrogen alpha. And we see the red color throughout the universe for these stellar regions where we have ionized hydrogen. And we see the blue regions throughout the universe where we have this small dust that is actually scattering starlight and causing these reflection nebulae, as they're called. They're really scattering nebulae because it's a scattering process called Rayleigh scattering that's actually causing it to be that color. All right. So we're going to save this now. Save it exactly as seen. All right. And that's your California Nebula. Look at that. I hope you enjoyed the California Nebula as much as it enjoyed you. All right, so let's go back to this here. Take that off.
Going back to the comet.
I am indeed. That's exactly where we're going. All right, so let's first, we're going to hop out of here. Come back to our night vision system. Night vision segment, I should say. All right. All right, and then we're gonna get our computer back up here. That is our system over here. There we go. And now we'll come back here. I think this is the comet coordinates that I had. Let me go see. We had several comets to look at tonight, but I want to see, they're behind my head right here. Okay, so okay, yeah, 2907. Yeah, that's it. So let's check it out. So off we go back to the comet. I had the coordinates pre-placed in here. Yeehaw! We should see the comet show up as a... there it is, down here. It moved that much. Look at that. Yeah, it's moving fast. So to see it, we have to bring it down into the field now, because the center of this field was where it was when I first came out here tonight, when we first got started. All right. We'll go to here, and we're going to go to the east a little bit. Beautiful. All right. And our focus is still good. There's the coma, the green coma of the comet. And there is the dust tail. The gas tail, the ion tail is here. And let's hope we can see it when we do this. If it's not visible, that would be because the moon might be up. I'm not sure yet, though.
Moon is up at 10 o'clock.
All right, so we're 15 minutes from that here. Okay. All right, so this will be a 25-second shot. Here we go. Underway. Back into our live stack. You see the California Nebula was the last image in the buffer. Look at that. Isn't that beautiful? Wow. That's really pretty. Lots of detail in this. It's almost like it's more detailed than it's ever been to me. Look at all this subtle detail here. Jeez. Well, that's up there now. So let's clear it and get ready for this next image of the comet. Okay, we have just 9 seconds. 5, 4, 3, 2, 1, and boom. There's the comet, and let's process to show the detail. Wow, look at that. Color correct. Yeah, look at that. There's the gas tail. You can see that very clearly there.
There's that red star again.
There's that red star, yeah. The red star was way down at the bottom last time. Because remember, the comet is going this way. And that's kind of in the direction of Mars. And that tail that you see right here, that tail is actually really, really, really immense. And it's going into the page. It's closest to us here, and it's going farther away from us all the way down this length. So you're looking at it like a train on a rails going down the train tracks. Hard to believe that, though, by looking at this. It looks like it's just going to the left, but it's not.
The dust tail does look narrower to me tonight.
Okay.
And it looks like the gas tail, the angle between the gas tail and the dust tail may be opening up too.
Here and here.
Yes.
Yeah, I see this. I see this length increasing here. See that? Yeah. So you guys having a good time checking out astronomical sights and sounds and all the other things we're looking at? And then checking out the comet. This is only one comet, that's in this region. There's another one in here. There's another one. And I wonder if we should look at it. I wonder. Okay. So these are the coordinates of other comets that are nearby. This is the one we're looking at here, ZTF. There's another one that's a Zwicky transient facility, and named after Fritz Zwicky, astronomer, Swiss astronomer, and his daughter Barbarina was in here earlier. It was nice to see her. We have this comet here, 2022 U2 Atlas. That's 5 hours, 12 minutes, 50 seconds. And they're nowhere near as bright as this comet, but they're there. And we could even see Halley's Comet if we wanted to. But its magnitude, its brightness is very, 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 very tiny. So it'd be hard to see. That means it's extremely highly positive. The brighter they are, the lower the number, and the negative numbers mean even brighter. For instance, the sun is minus 26, the moon minus 13, and the star Vega is 0. For instance, this comet is magnitude 6.5. Okay. Here we're going to save this as it is here, and I screwed that up. Okay, no worries. I saved it into the California Nebula one by accident, so I have to change it, and then it's going to say rename, yes. Thank you. So it might have done the rename for me, because it recognizes when I'm stupid. Alright. Beautiful. And then we have one. It's at 1 hour, 33 minutes, 33 and 51. That's in Perseus. And that's actually just coming up, isn't it? Is my mind screwed up here?
Perseus?
Yeah, it's on the other side here.
Perseus.
Oh, no, wait. Where's Cassie? Why am I thinking it's over here? It's not. I'm all messed up. No, it's not over here. Yeah, there's some major coming up. It's come over in Easties. Yeah, we're actually we're it's over here, and that's because there's a double cluster.
Perseus right there.
Yeah, it's right here.
Just above you.
Yeah. Right.
You were just in Perseus when you were showing California Nebula.
That's is that Perseus or Auriga? Might be Perseus.
Menkhib was Perseus.
Yeah.
It's right where Perseus and Taurus come together.
Yeah. Okay, so maybe what we could do.
Because Capella is actually westering now.
I know it is. Look at it. Look
actually,
at that.
all the bright stars of winter are westering now.
Yeah.
They're all west of the meridian already.
Mm-hmm. All right. So let's see the comet here again. What a beautiful comet. And we're clear to get a pristine shot of it without motion. We'll do that one shot and do that. Okay, so we'll save it. Just to get the motion if we want to actually do a motion animation. Okay.
I saw Cannon's Venetici under...
yeah, it was there. I saw it. You're right.
Ursa Major. Is it below the wall of the observatory?
I believe so. Let's go check it again. Because right now, we could look at, I think, M81 and M82.
You could.
So we got to zoom in to see those.
And there are other galaxies.
Oh, yeah.
Up in Ursa Major right now, too, I think.
Yeah, like, you mean the Whirlpool? That's Canis Venetici. Yeah, that's going to be down there.
Oh, M108, I think. I'd have to look at the star chart, but...
All right. I would like to look at these two galaxies while we're here.
Sure.
Because they're going to show nicely. Okay, so this is... we'll do one more shot of this. And save it. And then what we're going to do is go to these galaxies, check out the galaxies, and then come back to the comets. Comet. I'll commit to it. There we go. So we'll save this just as that you see it here. And save it exactly as seen. Let me see if I can make a modification to this while I'm here. Izabela is asking about the Cat's Eye Nebula. NGC 6543. Can you check on that while I'm doing this? All right. I think we talked about this before, though.
Talked about what?
Cat's Eye Nebula, NGC 6543.
Oh, we looked at it before.
Yeah, but Ben's recommending it. He wants to know if he can see it. That beautiful gas tail. We're going to save this. Yeah, it's looking nice.
It's in Draco.
Yeah. All right. That's just a pretty comet, man. That's just really, really special. All right. Let's get out of this. Go back to our night vision setup. And
the cat's eye is above the horizon, but it is very low in the northeast.
I thought so, actually.
I think it's below the wall of the observatory.
Yeah. You think of it as anything below 30 degrees above the horizon is not going to be good enough.
Yeah.
Okay, why am I waiting forever? Come on. All right. There we go. Okay, now we'll go here. You'll see the telescope move pretty dramatically here. There we go. Star streaks. Then you'll see some galaxies appear here. Here they are. This is Messier 81. This is Messier 82. These two galaxies have probably interacted before, and this is another one that may have interacted, but I'm not sure. I think this one might be farther, but I'm not sure. All right, let's see. Ralph, thank you for suggesting that nebula. As Cosmic Ray has said, we've seen it quite a lot. That's the Rosette Nebula. It's stunning. It never fails to impress.
We were there last stream, in fact.
Yeah. And that was with the moon out, and it was just beautiful.
Somebody said, speaking of, the moon is just rising in Arizona.
Mm-hmm. That's why I'm trying to get the deep sky stuff done now.
Yeah.
Okay. So we're going to focus on M81 tonight. Let me just see what we've got. Okay, it doesn't look like we have too much wind issue, and it looks like the stars are focused. See how noisy that looks? In the early days of electronic astronomy, that's what you got for a galaxy image, and you thought, wow, that's cool. Hi, Curtis Horn. What's up, man? How are you? I can't click on that link, Curtis, because it'll mess up my whole chat. And I'm doing 5 things at once. I'm trying to... What is that?
It's an image of the Comet ZTF, where they're tracking the comets to the sky.
Okay. So you see stars as streaks in the... Yeah, okay. I think I saw that one. I think I've seen that one. Okay. So we are guiding on this right now. So let's do 30 seconds on this. All right, and in our stream here, or rather our stack, we have the comet there. We're going to clear that. We'll be back to that maybe. There's the tail. It's very obvious. Okay. And we're going to do that. There we go. Yeah, the moon's up because we're getting a little bit of sky glow here, but nothing that we can't deal with like this. Look at that. Let me color correct here. So align all my curves. There we go. You notice how the curves which were misaligned are now really aligned. That's how that works. Okay, so let's make our space really black back there.
Somebody suggested the Eskimo.
Gemini?
Yeah.
It's small, but it's impressive.
I'm going to say it's small.
Yeah.
Wiki says it's 48 by 48 minutes. I don't think I believe that. Stellarium says 33 by 33.
Okay.
Or 0.33 by 0.33.
Let me pull back some of the interior detail here now. There we go. Okay, there we go. That's nice. So now you can see the spiral arms here. This looks really pretty. So we'll let this develop a bit. There's only 4 stacked images so far. Let's see if it wants to do. There we go.
Michael Hedrick, if you give it a little time, as I said a minute ago, the bright stars of winter are all west of the meridian now, and the stars of spring are coming up in the eastern part of the sky, and that's the stars of spring is when we see the galaxies, but you're just starting to show up as with these two now. We'll have to give it a little bit more time. Before really springtime is prime time, we should have a really good look at the galaxies. Marc mentioned the whirlpool earlier. It's a little below Ursa Major right now, and when it's higher up, we can get a look at it.
That'll be coming in the coming weeks.
Yeah.
A little wind. Stars are just a tiny bit elongated. Okay. Ralph Wooden says he's got about 5 hours on M82, which is this galaxy up here. And he said there was some light clouds, so the stacked images look so-so. That's okay, Ralph. Just stack only the best ones, which I think you probably do, right? Okay. There we go. Let's start to zoom in here. Okay, we got noise here that's going to be mitigated or making it go away. I also have I can use a bilateral filter here to kind of soften that noise. Yeah. I won't turn on the mask because that'll also sharpen the noise too. But that's really pretty though. Look at that. You can see H2 regions, these emission nebulae in this galaxy. Yeah, you got a little tiny elongation of the stars, a little bit of wind. Yeah, I figured, Ralph, you'd only use the best images. You certainly don't need me to tell you that, you know. Okay. What's interesting is this galaxy, Measure 82, it's called the Starburst Galaxy, and you can see that it has this burst of star formation coming out of the top and bottom. Very, very fascinating galaxy. How come that happened? Not really sure. It seems to be because of an interaction with this galaxy. See our spider web out there is bouncing around. So our image is a little bit soft here, caused again by the wind. So this image is not so good because of that. So I'm sorry about that. But, let's see if we can do darkening anyway. There we go. Neat.
Seemed like you were on the edge of some fine detail in M81.
Yeah, I mean, the wind, comes along and does some stuff, see?
Yeah. Well, if you look at that down at about 7 o'clock.
Right here?
Yes, that area. Looks almost like the faint arm of a spiral arm sticking out, hooking down to the lower left.
This here?
Yes.
Yeah.
And
it's going the right direction to follow this arm.
yeah.
Interesting.
Lots of details you pointed out in that upper part too.
Yeah.
Up at about 12:30 or 1 o'clock.
Up there, yeah.
So,
Yeah, we actually we lost some detail because the wind has kind of done a little bit of corrupting to our image, but that's okay. In any case, I could clear this and let this next image speak for itself. See the difference, though? So I'm not gonna save these because these images are not that good for tonight. Not a big deal. Let's look at. I want to look at the Medusa Nebula again too.
oh, I thought that was cool.
Yeah, we'll look at that again. Alright, oh, this is the surfboard, and we have the owl right nearby.
The surfboard.
Surfboard Galaxy, and the Owl Nebula is...
Okay,
Isn't it?
M108. I mentioned that earlier.
Yeah, but there's
also the whale, isn't it?
Oh, I don't think so. The whale is a different galaxy. But the owl is right here, so let's go to the owl, and we'll get the surfboard as well. This is pretty. So we're going to try this. So, first things first. We'll clear this. So you're going to see two objects, one of which is, I forget how far away the owl is, a few thousand light years maybe, and one of which is several million light years. So Daryl, I think, is looking it up now.
What's that?
The distance of the owl. Well, actually, we know the distance of the owl. It's about 2,000 light years. And then the Surfboard Galaxy right next to it is about 45 million light years. So we're going to go to the Owl Nebula. And
I always thought the surfboard and the whale were the same thing.
No, the Whale Galaxy is a separate galaxy.
Is that 109?
I don't know. But wait till you see this. There's the owl right there. This is a beautiful planetary nebula. And if we play our cards right, you will actually have to bring this down a little bit, and you'll see this the whale nebula or the whale galaxy in the same, not the whale, the surfboard galaxy in the same image. So let's do that.
No, 109 is not the whale. 109 might be visible though. It's in Ursa Major also. It's look.
Let's see, there's the surfboard. Let's just do that and the owl right now. We'll get to those. Whichever they are, yeah. So now we're going to shift to the west. And we're going to bring in a planetary nebula, the remnant of a dead star, which is down below there. And then the surfboard galaxy, which is actually quite stunning. And we're going to check focus too and make sure that, or wind rather, to make sure that we're okay here. So step one, let's go look at our focus. Actually, focus looks good. Okay. Okay. Let's do a 25-second shot here. Wait till you see this guy in this looks that's the owl looks stunning. So we'll stack it. First of all, get rid of the others. Okay.
Messier 109 is it's a very nice barred spiral galaxy. It's southeast of Vecta.
Okay.
In the bowl of the Big Dipper.
Okay, look at this. So this is beautiful. Wait until you see this with a little bit more detail in it. A little color correction. Can you tell why they call it the owl?
I can.
Yeah, there's the two eyes of the owl. Looks like a barn owl. All right, now let's ride up our curve here and darken this up. So the Surfboard Galaxy up there you see is actually quite an interesting looking galaxy. And we'll check that out. You can see it's actually it's a galaxy that has some pretty reasonably tight spiral arms, or it's like a moderate spiral. It's sort of edge on, kind of like looking at a dinner plate, kind of at it like an angle, like you see me doing with my hand here. Okay. On the opposite end of the scale, the dead star called the Owl, the planetary nebula here. This, if I sharpen it a little bit, you can see that in the middle there is the star, the remaining white dwarf in the center. Okay, there's the star right there. You can see that little white dot in there. There it is. What happens if we remove some of the color here? See, if we remove some of the green, you can see the white dwarf in there very nicely. If we put it back in, it tends to overwhelm it. But you'll notice the outside, we see this beautiful outside shell of glowing hydrogen ionized by that white dwarf in there. Now this white dwarf, this is oxygen 3, doubly ionized oxygen. This is probably hydrogen. So that white dwarf could be what we call a carbon-oxygen white dwarf. And that's stars more like the sun. Stars that are a little bigger than the sun. Then the difference is we're going to have an oxygen neon magnesium dwarf, basically a 1mg. Okay, and that means that we have degenerate matter, the electron degeneracy, but the primary nuclei on the surface are going to be on the bigger stars that are still going into white dwarf stage, oxygen, neon, and magnesium, as opposed to carbon oxygen, which is what I think this one is. I think this is a carbon oxygen one, the same thing that our sun would be. Michael, you leaving us? Michael Hedrick. All right, good night, Michael. Thank you for coming, and we enjoyed your company. We'll see you again.
Darn stellarium.
What about stellarium?
Oh, it'll show me one, but it won't show me another one.
There is.
Messier 106. You might like to try after this. Curtis Horn also recommended it.
Okay.
It's also there near Fecta.
All right.
Lower back star in the bowl of the Big Dipper. And
okay.
that's Messier 106. Messier 109 is supposedly in the same area, and I can't get it to come up. And 106 came right up, though.
All right. That's right, Ray. That's what I was saying earlier, as there's these two patches. If we zoom in one more time on the owl, you can see it. Okay, let's move it down here. There you go. Reduce the color a little bit. Will actually allow us to see the white dwarf. There we go. There it is. That's the barn owl's head. See it? So we have an eye right here, and an eye right here. That's our barn owl. Okay. It's amazing to think that by looking at this, we're looking potentially at the remnant of a civilization long gone because their star went nova. I'm sorry, not nova. Went into its death throes and ended up becoming a planetary nebula. And we don't know that for sure, But I think the universe is full of life, actually, based on the prevalence of carbon. Carbon just has a way. Very nice. Okay. So we have owl and surfboard. We're going to save this here with 15 done. We're going to do 16. There we go. Now we'll save it. Oh. Well, we will once I do this. Okay, so now we can save it. And save it exactly as seen. There we go.
Ralph, wouldn't
I don't. So what he said. What did he say?
How big is the dwarf star?
Oh, the white dwarf star. Okay, the white dwarf. That's the nice thing about these white dwarfs. We know white dwarf structure, and we know how most stars, of whatever size they are, that are kind of near the sun, a little above, a little below, that when they form white dwarfs, the white dwarf is about the same size, and that is about the size of the Earth. So imagine a sun, like our star here, is 1 million miles across, almost like 870,000 miles across. Imagine it being, in the end, 8,000 miles across. Okay, that's you know that's more than 1,000 times smaller than it was. So that's what our sun's going to end up, and that's because that material is getting compacted into the core. The core begins to collapse, and it gets to a certain point where the electrons basically push against each other, and it's like getting a checkerboard and putting electrons in every checkerboard spot, and you can't compress. You can only have one per square, you know, and the more you compress, the more they push back, and that's called electron degeneracy, and that's what we see in white dwarfs, and that's what actually holds up the white dwarf and prevents it from collapsing. But if you really add mass to that white dwarf, then it could collapse further or start spontaneous fusion, which can totally cause it to, you know, do one of two things. It could totally destroy it and become a type 1a supernova, or it could just fuse all that hydrogen that leaks onto it from, say, a white dwarf companion, a red giant companion, and do that spontaneous fusion and flare up really brightly for a period of time and then fade out. That's called a nova. Not a supernova, but a nova. All right, and so novas are out there. Type 1a supernovas are out there. Type 2 supernovas are out there, which is where the core collapses and the star just blows up. We've talked about that before. In fact, it's a product of neutrinos, actually, destroying the star in the end at the final moments. You know how stars make all these elements in their cores? Well, here's something for you that you may or may not have known. The elements made in the cores, you know, of the star, by the time they get to silicon for the bigger stars, silicon can be made into iron, all right, and it can also decay into other components as well and go back and forth. But it'll make iron and nickel next. But you know how long silicon burns for? How the fusion cycle, the time in a star, and say if it's a big star, it's only going to live about 10 million years or so. Silicon is made in only 1 day. 1 day. So all that, you can imagine how fast and furious it has to be happening to make all the silicon that we see. So that's how much is made. But silicon fusion occurs for only 1 day in the life of a star. Okay. Let's just do one more of these. Save exactly a scene. Alright. Now we'll clear it. Which one do you want to go to, Daryl, you said?
Messier 106.
Okay. Messier 106 it is.
I don't think it's far away from where you're looking.
Probably not.
Well, there's Spectre right there.
Yeah, so I'm wondering if this is it. That's not it. Might be right below it, though. That's 109.
That's the other one I was wondering about. 106 is in the same area.
Is that 106?
106 is actually a little bigger than 109 is.
Okay, then we want to... Let me search for it because... let's find out where it is. Ooh, that's way down there. I don't think we can see that.
Well, where were we?
Well, we were way up there. Oh, wait a minute. It says it's 33 degrees above. Alright, you know what? We'll try it. I mean, the worst that can happen is the telescope can't see it.
Alright, well,
Here we
try
go.
this and maybe try 109. 109 is higher.
Yeah.
It's funny, I couldn't get 109 to come up in stellarium. There's actually closer to effective than 106
Yeah,
is.
see where the telescope's going?
Yeah.
It's close. It's right there. We might luck out here, but it looks like we might have a little bit of interference. But let's find out. All right, so we're gonna actually bring the telescope north a little bit. And we're gonna go west a little bit.
Probably just peeking over the roof there.
Yeah. Okay. We'll try this. Let's see what this does. Is there another one here?
Kind of looks like.
It might be. Looks like one right here. Looks like one right here. Looks like one right here. Pretty sure it is. Okay, let's do this. Let's do let's do a 25-second shot. All right, that's underway. Let's get out of there. Go into our live stack and remove this. Okay. Now we'll see what we get. And this is good because the Medusa Nebula will be high in the sky by the time we shoot it, because that's a really nice nebula.
Okay. Yeah, I would like to see that again.
Yeah. Oh, look at that. Yeah.
That isn't a...
We got
I
1,
see
2, 3, 4, 5, 6, 7. See, there's 2 right here. 1, 2, 3, 4, 5, 6, 7. And that's... And now we haven't even...
Yeah. An article or someplace said it was one in a group of galaxies. So
Oh, yeah, well, it's definitely...
there you go. And this rings a bell. And Ray said that M106 has a water vapor mega maser
Okay.
in it.
Now, this is a good... Look at the size of the extent of that galaxy.
Folks, this is just a preview of what we'll see in the springtime in the coming weeks and months.
Galaxy season.
Yep.
Aside from the several hundred to several thousand stars in this field of view, counting all these galaxies, you're actually looking at many hundreds of billions of stars.
Yep.
This is a lot of freaking starry skies here. Let's bring this over here. This is actually kind of good because it shows some of the details. Is this a barred spiral?
Yes,
It looks it.
I do believe. It's an intermediate spiral. Active nucleus classified as a type 2 Sapert. Supermassive black hole.
Look at that. That's pretty exciting. I took the enhancement off because... oh, I left it on. Let me turn it off. See if we can see some more detail in there. Yeah, there we go. Because if you put it on, you get sharper arms and details, but it sort of overblows the nucleus. But I could compromise by just taking this down to, say, 1 or 0.9 actually. That's all right. Nice. Look at all these stars in these galaxies. It's like this one galaxy here. Who knows what's going on in this galaxy? You know? Who knows what's going on in this galaxy? Or that galaxy? Or that one? Everywhere. Look at that. Amazing. Okay, this is 10 shots here. And this is M106. M106 region. I'm going to put GAL for galaxies. Thank you, Izabela, for putting up that information for us. I'm sorry I haven't been seeing chat as much. I didn't notice that you've been putting that up. I knew you have been, so I apologize for not responding to it earlier. Okay, we're going to save this. And then save it exactly as seen. Okay, that'll be up there for you to see. Right, so now, let's pull out of this here.
You want to try 109?
Maybe. Let me, I'll try. Sure, why not try?
It's not as big as 106.
Okay.
It is the one higher up towards Vector, though.
All right.
And it is a barred spiral.
Okay. Yeah, it's up there. All right, let's go see. And we're going to change our time here. And we'll be joining this show already in progress. Meaning that the streaks are already going to be happening. There it is. Very nice. All right, let's move it in. Move west a little. And head north a little. Isn't this cool, guys? I mean, I don't know. I've never lost, as Daryl yawns, I've never lost the enjoyment or the awe of being able to look through a telescope that was just so incredible. Okay, there we go. Let's go see. That's funny, Bonnie. Okay, let's do 25 seconds here as well. It just is incredible, and the time just flies by. I don't know where it goes. You know? That's beautiful. Okay.
There's a crazy picture of that at Wikipedia. Of 106.
Okay.
All sorts of stuff coming out of it.
All right. Here's 109. I know you don't see it yet, but we gotta process it in. Here it comes. Well, that's neat. Little tiny galaxy. But clearly, that's definitely a barred spiral. A barred spiral, guys, you can see it actually when you zoom in here. It'll be a little fuzzy in the early stages here. Well, let's check it out. Notice how there's this line coming through the center here? That's a bar in the nucleus, and the spiral arms come off of it like size that a farmer uses. You know, the SCYTHE. You know, and that has that shape of the blade. That's the shape of the arms. Comes off of that bar in the middle.
It looks like a steering wheel.
Another steering wheel. There's another one right here.
Yep, another one down below it.
Right here. And right here.
Yep, that one.
Wow.
So is that effective right there in the upper right?
Let's find out. Yep.
Yep. Okay.
Because remember, you gotta the writing has to be up. This is also called the vacuum cleaner galaxy. Whatever that means.
I guess I was looking too far away from effective to see it.
Maybe. Okay, so that's okay.
Thank you, Izabela. Oh, that's all right. Not as good as 106.
Yeah.
You want to go do the Medusa?
Yep. Curtis asked about M64. I don't know that we can get the M64 at this point, can we?
I'll find out.
Well, I can also do it here. Let's find out. Oh, no. Black Eye's not
Oh,
going
the
to be...
black eye. No.
Yeah, Black Eye's not going to happen yet, Curtis. It's a little too low.
Yeah. Comet Berenices.
Yeah, we need to... It's only like 18 degrees, 18 and a half above the horizon. And we have a 28 degree top of the roof. So, good try though. And now what we'll do is we're going to do this beautiful nebula here. It's at 70 degrees up, and it is in very good position. So we're going to go here. This is called the Medusa Nebula.
Izabela, I remember the name, the vacuum cleaner galaxy.
I remember that too. That's just,
We have looked at it before. No, it is coming out soon there now.
yeah. I'm actually not going to save this one. I'm sorry.
That's fine.
And then we're going to go here, and we're going to join our show already in progress, as I say, because the telescope is already moving. There is the Medusa Nebula. Awesome. All right. Very nice. So now we're going to go south a little bit.
I was really struck by this the other night.
Me too.
I had to get up and see a man about a dog, and when I came back, you were gone already.
Well, what do you expect? Well, tonight will be different, because if you look where we are, it's directly overhead almost. It's at 70 degrees altitude. This will be pretty nice. There we go. So now, when this comes in, we're going to... I'm going to go a little bit west here a little. We're going to focus on this and get some really good images of it. As long as we don't have wind affecting us too badly.
How long an exposure are you going to do?
I'm thinking of doing like a... Try 45 seconds. Make sure the wind doesn't affect us too much. All right. Here we go. This was a planetary nebula, right?
Says it's an,
Is it a mission?
well, Emission and planetary nebula, it says both.
Okay.
Very large, very low surface brightness. It says 10.25 by 10.25 arc minutes.
Mm. That's what it looked like on the screen.
Blah, blah, blah. Yeah, planetary nebula, constellation Gemini.
Okay. Alright, so here we go. Look at that. Wow. Oh my gosh, that's just beautiful. Let's get some processing on this.
I remember it was very
Look
colorful.
at
the
that.
other night.
Look at that. Wow, that is just stunning.
Still looks like a chili pepper.
Okay. I won't say it doesn't, because it certainly does. Look at the filamentary structure, guys. That's amazing. It looks like it curls around here. Oh, this is going to be a showcase object, I can tell you that. Oh, this is a Medusa Nebula, and it's a PN for planetary nebula.
You know, we talked the other night about which star was the progenitor, I guess.
Yeah, I think this is the one right there.
I thought we thought it was the one to the lower left.
Am I here?
Yeah.
No, I don't think so. But maybe. I was trying to see the sphere. I'd have to look and see, because I see the sphere continuing here.
I know what you're saying.
So I thought it might have been this star here or that star. Actually, the giveaway would be whichever star is bluest might be the one, because it's the hottest star. It's the white dwarf, and that looks like this star is actually blue. So we'd have to check. Look at these filaments, my gosh. Oh, that looks stunning. Holy cow. We need to go into SEDS or one of the other databases to figure out in reality what star looks like the progenitor here.
Curtis says,
Yeah, I'm reading it, yeah.
this was the small blue dot within the overall bright crescent shape.
Yeah, so we're looking for the small blue dot, and that could be the blue dot. Actually, let me saturate the colors a little, because I actually have them kind of suppressed right now. Oh my gosh, look at that. There's the blue dot. That's it right there. Look at that.
I see.
That to me, that looks like the white dwarf.
Says it's within the bright crescent shape though, and that's not really in the bright crescent.
Oh,
It's blue.
yeah. You know, to me that's. Zoom in again. Zoom in some more. That looks like the white dwarf right there. And that's in it, if you think of this as being part of it. And geometrically, that makes some sense.
It does.
All right, let me add some enhancement back in here. Let's go over 1 pixel here. Yeah. Definitely blue. That's definitely the white dwarf. You can't miss it right there. So that guy right there, there's your white dwarf in there. That's 40,000 Kelvin on the surface. Not sure if it's a carbon oxygen or oxygen neon magnesium dwarf. But it's going to be very hot. It's going to be giving off a lot of ultraviolet energy. It's not putting out any fusion at all. It's not doing any fusion. It's just the leftover remnant of the core, which is extremely hot. So It's ionizing oxygen, which is the bluish green in here. It's ionizing hydrogen, which is the reddish in here. Look at that. That is just stunning. Really, really pretty. Holy cow. Showcase object. Can't miss the blue. Yeah. That's what I said before. Look for the blue star in these things, and that's usually the white dwarf, because they are hottest. They're the hottest, and when you get really, really hot in the spectrum of stars, the hotter they are, the bluer they are. So when they're really blue, they're really hot. Yeah, no question now, Daryl. Look at that. That's clearly the white dwarf. I just love these filaments. How complex. And it looks like it continues around here, too. Now, you might say, well, then why is it all on one side? Well, it could be expanding out in here and expanding out here, but this side of the explosion area, this could actually be an area where there's material in the interstellar medium that's sort of causing it to snowplow and slow down as it hits it. And then it would make it that much more visible, and that would in part also assist it in glowing. And the material over on the other side may not be as dense, so it's actually expanding outward far enough, because there is a filament right here. You can't miss it. There's a filament right there.
There is a whole lot more there that you're barely touching on.
I'm sure there is.
The image at the wiki, and Ray posted an APOD image of the Medusa. The orientation is different in the images, but if you look at that like an open cup,
yeah,
what would be above the opening of the cup to the upper right in your image, there is a whole lot more out there that you're barely touching.
Yeah, and that's because we're only doing a 45-second shot.
Yeah.
What I'll do is I can come back to the Medusa and pursue it. Pursuta the Medusa.
Call that the Jalapeno Nebula.
I know it, right? So we can now see if this was a black and white camera. That's all this would look like. That's not exciting. I like seeing the constituents, and of course we go all the way up, and it's like way too gaudy. So it's about the middle is where I put it. Right about there, yeah. All right, so then this goes down about here.
It's interesting in that APOD image Ray linked to. It talks about the central star. It's so tiny in the APOD you can't really make it out.
Yeah. Well, we see it.
Barely make it out.
Yeah, we see it here. Amazing. Well, what's nice is this is a first-time object for us. We didn't see it until the last stream, and it's really neat to see it now.
Yeah, I don't know if you'd call this a happy accident or what. Maya Leon, remember, asked to see the Medusa cluster, she said. And I Googled Medusa cluster, and Medusa Nebula is what came up, so this is what we looked at.
Yeah. So that's this guy right here. And let's color correct and see what we got. Alright, here we go.
Izabela says it looks like a firebox.
Yeah. It does. Looks like that. It's like the Firefox logo. She's right. So we're picking up more stuff out here now, see? Yeah. And we're actually really pushing. Actually, if we let's see what else is out there. We'll use this one. Oh yeah, look, there's a big stuff out here. Everything's a lot of stuff out here. That'll come out when we process.
Might be in the background. There's a lot of red to the upper right there.
I see that. I'm wondering if that's actually real or imagined. It could be real. Interesting. And we see a lot of green here. Alright. Let's try something else. Let's do this. I'm gonna pull this over.
Ray posted another APOD of it. Both images are, it looks like it's showing only hydrogen and O3 oxygen.
Mm-hmm.
The second image, though, does clearly show those red, the red areas to the upper right.
Oh, good. So that's real.
Yes.
If you notice, we're starting to catch all these now, and this stuff.
Yeah.
So we're seeing it. So
yeah, that red stuff out there is real. There's two distinct lobes of it.
well, there's one here too, and one here. So, and this isn't the Wolf-Rayet star situation. This is actually a planetary. Wow.
Cool.
Yeah, it's just really nice. Let's soften it just a bit. Now, reminiscent of the crab, a very different object, very different type of genesis. The supernova remnant, we actually see filaments in this too. So filaments are not constrained only to supernovae. They're also something that can show up in planetary nebulae, which are the slower, more gentle deaths of the stars.
Yeah.
There's a lot of stuff. Look at that, a lot of stuff out there. Yeah, this definitely is going to be a repeat visit with. This is going to be a repeat visit, without doubt. Alright, let's zoom out a little bit and see what the whole field shows. Yeah, look at that. There's a significant amount of stuff in here. Best shot of the Medusa we got. Izabela asks, any news on a new observatory? We're actually still doing acquisitions. We're going to get the new camera soon. Probably be testing it on this system here as well. So we'll have that camera working on this system as well.
You know, with the longer focal length telescope, while you're
That'll be beautiful with this.
Yep. While you're imaging with that one, you'll be getting half a dozen images with this one.
That's right. And that's exactly what we're going to do for those listening that are wondering. We have two observatories now. The one out here is being rebuilt, and that telescope sits behind me here in the office. I showed it to you before, but real quick, I'll just show you again. If you look over here, back there, that's the new telescope. Not the new telescope. It's the telescope for SkyTour LiveStream 2, or 1 rather, which is East Coast. SkyTour LiveStream 2 is SkyTour West, which is actually in the Arizona desert, the one we're using here. And then SkyTour 3 is the third telescope that's going to go in the next building, and that one is a longer focal length system where we'll be able to basically, in a native manner, okay, we'll be able to look at this guy here. Let me give you an example. We'll be able to see this just natively. It's going to be about this big in the field, maybe a little smaller, maybe about like that. That'll be the native size of the object in the field. All right. Right now we're pushing pixels here. We're at 184% on this camera, and the native size of our sensor, actually, I'll show you right now. Okay, the size of the image that it wants to be is right here. This is how big this image wants to be. All right. And when we process them, that's the size you get for the upper tiers in the Patreon. Remember, you got to go here to SkyTourLive.org. In the upper left of SkyTourLive.org, you can see a link to this stream here and all that we do with SkyTour LiveStream. And to the right, okay, you got SkyTour LiveStream here. To the right, you have the Patreon. You could join us and for a monthly subscription, get you know, for the higher tiers, you get fully processed images. For as little as $10 a month, you get 4 of our highly processed, beautiful images per month. All right, and they rotate, and you have access to those directories. You can download them, do whatever you want. Start building a collection. For $100 a month, you get access to all the images that we have in very, very high res, and we have about 35 of them now that we've done. And you can do anything you want with them except sell them. And if you want to go even higher, if you want to go to 200, we actually have a $200 patron. Then you get a session where you come in with us once a month, and you get to go anywhere you want in the sky. And you tell us what you want. If you don't know what you want, we'll help you figure out what you like. If you like planetary nebulae, we'll find all the cool planetary nebulae with you, and you'll be on the air with us. And do this, and that makes it really cool. So after the second consecutive payment, that's when you get that benefit. All right, so it's pretty cool. All right, let's see if we can look at that. That's looking really nice, man, I have to say. All right, this is a Medusa Nebula. We're gonna save it here at 23. And save it exactly as seen. Wow, I can't wait to process that and have some fun with that. There's a lot of data in there. All right, did anybody have any other objects they wanted to look at? It's actually 1 a.m. so maybe
well,
we
let's
could
look at the comet.
I was going to just say, why don't we just go back to the comet, right, and check out the comet. So let's, first of all, say goodnight to the Medusa Nebula. That really looks pretty. All right.
That's really something.
Yeah, and we'll pull that out of there. All right. And now what we'll do is we're going to go back to our comet here. We're going to go there. Okay, and that'll be up in a second. So let's clear this. It'll be up on the site here in no time. And now let's go back to our night vision mode. Ray wants longer exposures. I would do longer exposures, but we'd have to have the understanding that we're going to be doing longer exposures for an evening. I don't want people to, wonder what's going on, because it's a whole lot of nothing while you're waiting, right? Okay. All right, off we go now to the comet, and the comet's going to be pretty far south of us. in this image here. We're gonna have to drop it down.
Mark, I dropped the links to those two apods in your chat.
Okay.
You can refer to for comparison to your image of the Medusa, may give you some ideas for processing.
All right, thank you. I will check it out. Oh, wow. You betcha. That's cool. All right. Don't worry, folks. You got a chance to see it. All right. Right now, I'm going to go south because we know the comet has gone south in this image. It'll come into the image here in a few seconds, I'm going to guess. There it is. That's amazing. And then we're going to go to the east. And we'll try this because we know that we know where that tail goes. All right, we are now guiding. We are all up in that. All right, here we go. This will be. Let's try a 45-second shot because I want to see if we can grab the tail as well. All right, that's what we'll do. So let's do that, and we'll go into the live stack. Check out our upcoming comet. Izabela, thank you for posting the Medusa image. All right.
I believe that's not better known.
I know. I don't know why it's not. All right, this is the 45 seconds at 350 gain on the comet. And here it comes. Oh, yeah. Now let's process this a little. Get the colors aligned. Oh, the tail, look at that. All right, and then we'll back out now. Wow, look at that.
See how far the red star has moved.
Yep.
To the left now. It was below it earlier tonight.
That's not this star?
Nope. The red star to the left is the one that was
All right.
taken note of earlier tonight.
No, that's good. Yeah, it's definitely moving. Ralph, this yellowish, this is the dust tail. You got to keep in mind that we're looking at this comet after it's passed us, you know. So that dust tail is past the nucleus of the comet in the distance. It's behind it. All right. And this tail here, it's closest to us here, and then it goes into the page in a steep angle, kind of like looking down railroad tracks going into infinity. That's like, this is the closest part of the train. That's the farthest part of the train. So that's how far away that is. It's actually going off into the distance. MLR asks, how long will we be able to see the comet for from this point?
I was just answering.
I think we can see it into March.
Yeah. The question might be, how long will it still be interesting looking?
Yeah, it's going to get inert after a while where the sun's glow on the nucleus here, causing it to be green. That's going to fade away slowly until we don't see it anymore as anything but sort of a glowing head of a comet. And it's going to get less and less and less detail. Hey, Lubo in China, how are you? Last time I had a question. Let's go here while we're waiting. Go into the settings. Go into plate solving. Right here. Yeah. I'm using ASTAP right here. So I have the ASTAP system right here. It's on my system. That's a plate solving software. So I'm not sure. Not sure what you're doing to stack that with ASTAP. I'd be curious how you're doing. I haven't played with ASTAP other than to use it for plate solving. So if you know that, that's cool. That's new information I'd like to have. Oh, look at this. That's really pretty. This is really the I think the first night where this tail has been so blue to us, you know. Let's saturate it some more. Look at that. Michael Klagas says they're saying it may break up. If it's showing signs of breaking up, I'd be really interested to see that. Yeah, that's correct. That he's saying to Lubo, it would have to track the comet and not the stars. Not bad, though. Not bad at all.
The gas tail looks maybe a little more obvious now than it did earlier in the evening.
Yeah, but then again, I'm doing a 45-second exposure when I was doing a 25 earlier.
Oh, okay.
So there's that. That's really pretty. Okay, let's go up here and save it as the comet again. All right, that was pretty cool.
Even with the longer exposures now, the fan of the dust tail still looks narrower to me.
Yeah, you've been saying that, so there might be something to that. I'll have to look. We'll have to see. Alrighty, well, that's pretty cool.
The head of the comet looks a little more elongated also.
Does it? I think that's just from the time exposure.
Alright.
So, we'll clear that. And
maybe I'm starting to see what you saw on the last stream where
shadow in the nucleus.
yeah, it looks almost like a saturated or something that's kind of burning out in the middle.
Okay.
It had a darker spot in the middle.
Well,
I think Izabela, I think, wondered if that was what she was seeing as the dark spot in the image she processed.
yeah. Maybe. Let's find out here. Let's find out what this... See, 45 seconds is going to elongate the nucleus slightly anyway. But let's see what it looks like. Okay. Very nice. That's a very pretty comet. Why did this one get the name the Green Comet when they're all green?
Yeah.
I don't know why that happened.
Media trying to get people excited about it, I think.
Maybe so. Yeah.
It is noticeably green.
Yeah, well, so was Comet Neowise.
Yeah.
And Neowise actually had a better tail than this one. The orientation in its orbit was different, so we could actually see the tail pretty clearly. Look at that. That's pretty, though.
Yeah.
Let's just move this over so we can get at this and do that. Alright, so now you get to see some detail in here. Wow. Okay. Ray's asking to see our field of view. Well, actually, we're not here anymore. We're over here. So let's move over there.
Well, that's well over in the west now.
Yeah. There we go. So it's going to be down here tomorrow. And we'll stream when it's going to be in the same field as Mars. But you saw how bright Mars is going to be, so it'll be kind of interesting to see what that looks like together. It'll be neat. Michael Glagus, Rocket City Astro, says, "Hello, LOL. I was yelling at the news people calling it green. They're all green," he yelled. Yeah, of course they are. Ay. And if a comet did come through within the moon's distance to the Earth, that would be the comet of the millennium, actually. It would probably, potentially, depending on how close it got to us, could potentially break up from the gravitational tugging if it reaches its Roche limit, reaches the Roche limit of any object.
Took the words out of my mouth.
Oh, okay. And that could be potentially catastrophic for us if they start to orbit the Earth and then spiral in and strike us like they did on Jupiter, one after the other. So let's hope that doesn't happen. Okay, let's go back here.
Per what Michael said, Rocket City Astro was Michael Glagus, right?
Yeah, that's Rocket City.
Yeah. The media, I mean, they usually say if it bleeds, it leads.
Yeah.
In this case, maybe they'd say if it's green, it leans. Sorry, that's all I got.
It's all right. At least you thought about it. Kermit the Frog is a sponsor. That's funny, Cosmic Ray. Look how blue that is, though. Look at that. That's spectacular. I'm going to save that because that is just spectacular. It's named properly. That is just a spectacular blue. Really, really liking this. So we'll be able to, selectively bring out that, keep this down low, and make this stuff brought out. So we'll be able to do that. It'll be kind of cool. Kind of like the eye would see it. Neat, man. Wowie. Wowie indeed.
Cool beans.
Yeah. Well, we're looking like we're almost out of things to not things to see. Of course, we're never out of things to see. But we're gonna wait. Tomorrow the moon will rise even later. Tonight was 10 o'clock. It's gonna rise later tomorrow. Out there. So we will be able to see all kinds of wonderful things starting up tomorrow. But tonight, I have to say, as of now, we're going to call it for tonight. This was a great night. We saw some wonderful objects. I want to thank you guys for coming along. Honestly, I can't think of any better people to have with me doing this than you. Barbarina's Wiki, thank you for coming out. She says, Mark, during your visit to Pasadena, stop by the Cahill Center for Astronomy and Astrophysics for this Wiki slideshow presentation in the lobby. Provided most of the never-before-seen images. Thank you so much, Barbarina. I will do that.
That'd be cool.
Yeah, I would love to actually. I'm gonna also get to JPL and see if I can find out where Gentry Lee is, because I owe him lunch or a coffee for getting me into astronomy. Very cool. All right, guys, thank you so much for coming tonight. We had a great time, all of us, and don't forget, these images of this guy right here will be up there on the server in just a few minutes. I will save this guy anyway. Again, save it exactly as seen. All right, and now it'll be there in just a few minutes. So thanks, guys, for coming out. So good to see you, and we will see you tomorrow night when we stream this again. It's gonna be glorious. So we'll see you later. Good night.
Good night, everybody.